this all this is. Great. Yeah. You can put them on the spots where there's empty chairs. Just
So when people sat down, they could grab it as they come in.
that also works.
You could also
Should I put it on the what's it called? On the slide? Yeah. I'm good, thank you. Okay, I just put it on here. Those are all. Yeah, one thing is like, people are gonna be on their laptops, so I don't want to have too many slides, you know, because they're gonna see what we see. Yeah. That would be good. Did you push your changes? Did you push your changes? Okay, no problem.
The exercises got exercise got stuck together with the exercise text, but it works in Jupyter.
Got it.
So one of them is wrong, so I think
No problem. It doesn't look terrible, so it's totally fine.
it's great. It's all this one. It's all forward.
Sweet. All right. We are starting in about 3 minutes. If you have the chance, please go to motherduck.com/SciPy and start taking a look at the notes there. We're going to give everybody 2 Post-it notes, one yellow one and one of various color, like lavender, pink, blue, pick your favorite. Then we'll get started with the tutorial shortly. If you have a chance, join our community Slack. I already see somebody joined. Thank you for that. Mirror. See if this works. Let this work. Wonderful. Hmm? we should just swap that. We got a break too, so it should be okay. Let's get started. So I will start by introducing the three of us, and then I'll hand it to you for intro to SQL, and then I will start with section 1. Break.
Good morning, everybody, and welcome. Thank you for being here at the lovely 8:02 a.m. in the morning. Welcome to All the SQL a Pythonista Needs to Know. So we're excited to have you here, talking all about language that's been around a little while, even older than Python. So hi, I'm Alex. Also going to introduce Gwen and Elena, and we're excited to have you here. So, you want to say hi first?
Sure, yeah, thanks. Hi everybody, my name is Gwen Prawiroatmodjo. I'm software engineer at Mother Duck. I'll be presenting the first section. After that, Alex will take the second and third section, and then we'll go back to me for the last section. I'll also introduce our duck friend over here. I couldn't come up with a better name than Trojan Duck, or you can call her the Mother Duck too. She's got all her little ducklings in the back. You might wonder, why did we bring this duck? It's not just swag distribution. You can win a prize. You can win a prize. Yeah, you'd think this duck might not need this hat, but so if at the end, so there's this website, motherduck.com/SciPy. If you go there, that's a feedback form, and the last question of feedback form is, how many duckies are inside of our duck-shaped tub? At the end of the day today, we will announce a winner, because we do not know, in fact, how many duckies are in here. So this is a double-blind contest. If you win, you get this copy of our favorite board game. It's called Abduction. It's about abducting little ducks in little formations, and it's quite fun. You will also win a Mother Duck t-shirt, and you will win this Mother Duck hat. So you are allowed to come here and take a look. Of course, you cannot take them out and count them. Please also don't take pictures and do all these AI stuff. So just use your duck tuition. All right. Let's say hi to Elena. Sorry about that. Elena, do you want to introduce yourself?
Hello, I'm Elena Felder. I also work at MotherDuck, and I like databases, SQL, programming, and bugs, because eventually you solve the bugs. And I would like to unequivocally state that in this weather, that duck needs that hat. And so probably do you.
All right, and Elena's going to be running around helping answer questions for you. That's part of what the Post-its are about.
One more thing about swag. We've got 4 of these mugs and with a t-shirt in it. I just put some random sizes in it, but if you win a mug, you get your size. And we already have a winner for the first section. We're going to give away this mug to the first person who joined our community Slack, which is Hongsup. All right. Give it a hand. Thank you. If you need a different size, just come up right up. All right, I'm going to now hand it back to Alex, who's going to talk about why SQL.
Fantastic. Well, I also work at MotherDuck. I'm a forward deployed software engineer there. I spent 9 years at Intel becoming a data person. So I'm a big fan of data. And I'm also a resident SQL hype man. So I'm here to talk to you about why SQL. SQL is a 50-year-old language. What do we love about it? Well, it turns out it's still quite popular. There's a famous prediction that the amount of time a language will probably last is best predicted by how long it's already been around. So SQL will be around for probably another 50 years, longer than we're writing code, hopefully, if we plan it all out right. It's also an incredibly popular, powerful tool in not just data analysis, but also data science. It's ranked in the top 3 of languages that you need to know for data science, and for good reason. SQL also means freedom. Freedom to pull your data out of the database that has it in its clutches, that is keeping you from getting your job done. SQL is freedom, SQL is independence. It's the ability for you to walk into a company and get started without waiting for somebody else. It's a way to get your job done faster, have more impact, get your analysis done. We are here to talk about our favorite flavor of SQL, DuckDB SQL. It's also what the same engine that powers MotherDuck, where we work. But this is very core concepts that are applicable across SQL dialects. SQL stands for structured query language, not standard query language, unfortunately. So they're all a little bit different. So that makes it really fun for LLMs in particular. But we're going to teach you the core foundations, and it's going to be a crash course, so get ready. But we're excited to have you. And I will pass it back to Gwen.
All right, I was totally not sending my colleague the link to the forum because it doesn't record emails. We are very well organized. Okay. Cool. All right, so like we said, go to motherduck.com/SciPy. That will take you to our form over here. Let's see, how do we want to do this? Get started here. So I'm going to walk you through the setup instructions real quick. So we are going to run this in Colab, Google Colab. If you have a Colab account or a Google account, you could just click this link, and then it will start Colab, letting you authorize with GitHub. Then it will show you 4 files. Can I get everybody's Post-it note on the corner of your laptop, the yellow one, if you're at this stage? So take your time, but basically just click this link. If you don't have a Google account, you need to sign up. Got everybody? Oh, we need more Post-it notes. If you don't have a Post-it note, please raise your hand and we will come to you and give you one. Okay, while we get that all sorted out, if you don't have Colab or don't want to use Colab, you are also very welcome to run a Jupyter Notebook on your laptop. The instructions for that are here in Setup Instructions. You can clone the repo, create a virtual environment, activate it, install the dependencies, and start the Jupyter Notebook. The last option is to run it in MotherDuck. Since this is a Python conference, we opt for a Python solution. But for the parts that only require SQL, you can also go to MotherDuck. You should have already gotten instructions to sign up for MotherDuck. If you haven't, we will have a good chance to do that later. All right. I'm just going to go real quick over how we're going to be running SQL queries, because we're going to be in a Python environment. So luckily, Python plays nice with SQL. How do we play nice? So there's a package called DuckDB that you can pip install that we're going to be using. If you're in Colab, I always recommend using -- upgrade when you pip install, because Colab is running a little behind sometimes with which DuckDB version is on there, but they do their best to keep it up to speed. Then Magic DuckDB is a package we'll be using to run SQL in Jupyter cells. You can load that here using the load extension Magic. The notebooks that you saw earlier that you can load in Colab will have this at the top of the notebook. Then we'll be using the %% DQL command. So that's DuckDB SQL command. For 2 percentage signs, it's cell magic. With just 1 percentage sign, it's line magic. So we'll be using cell magic. And then your SQL query is going to go right below that. And after this tutorial, you'll know what select 42 does. Then a little note about DuckDB. So DuckDB is an in-memory OLAP database, but it can also be persisted on disk. So typically, we'll be using DuckDB in memory mode. That means is whenever your Python kernel shuts down, your data will be gone, will be dropped. But if you would like to retain your data, which we'll do later in the tutorial, and we'll all go through this, but I just want to make sure everybody's on the same page. We connect to a DuckDB file like so. So you import the DuckDB package, you create a connection, DuckDB.connect, and assign a file like this. And then you can pass that connection to the DuckDB magic command. And that means that if you create a table, it will be persisted on disk. And then, MotherDuck, we'll go over this in the last section 4. If you want to connect to MotherDuck, you just need to use the MD : prefix, and you need a MotherDuck token. But again, we'll go over that. Then how to access files. All the notebooks should have everything in the cells that you need. Anything that's missing, it will be an exercise. But basically what we've done at the top of each notebook, we have some wget commands that will download files into your notebook environment to make it easy for you to just run it. If you want, this is totally optional, you can also mount your Google Drive in case you have any files there you'd like to inspect. All right. So before I dive into that, we have 4 chapters today. We're going to spend about an hour on each. As I said, I'm going to be presenting section 1. Then we'll go to Alex for section 2 on more advanced SQL commands like joins, subqueries, and combining SQL and Python. And then we'll go back to me for collaborating with data in the cloud. All right. I assume everybody has their Post-it notes. Everybody has their Colab running. All right. If any time during the tutorial you need help, or you're stuck, or you have another question, put your purple, blue, or pink Post-it note on the top of your laptop, and we'll run right to your desk and help you out. All right. Elena, we've got a question right there. All right. So let's get started. All right. So I'm going to take about 20 minutes to talk about some basics of SQL. There will be exercise interleaved with the instructions. I'll pause for a few minutes, and then after you finish the exercise, we're going to ask you to put up the yellow Post-it note again. All right. So like I mentioned, DuckDB is a high-performance analytical database system designed for easy integration with Python, actually, with data science workflows. It works great with in-memory processing. We believe SQL is an extremely useful skill to have in addition to Python. And hopefully it'll be clear during this tutorial. So let's dive in. So to start off, you can open this in Google Colab. Go to number 1, Intro to SQL 1, and then open this. All right. So we're going to start off by installing DuckDB and the magic command, and loading the magic command. So it's going to ask you, do you really want to run this? And you say, yes, run it. Also, in case you're wondering, there are indeed corgis, crabs, and cats running on top of my notebook. Yes. Okay, one sec. Elena has a comment. The initial GitHub repo. Sorry, Do you mean motherduck.com/SciPy or?
Yes, you can
Yeah.
start there.
For the people who just walked in, please go to motherduck.com/SciPy and follow the instructions there. This is the link you want to go to. All right. So we'll start with some downloads. So these wget commands are going to get a data set called Washington Weather .csv, which is a data set I got from NOAA. And then it will also download the answer key. So I'll show you in a bit how to load the answers. Okay. So first off, 101, how do I create a new table? I'm just going to increase the font size a little bit. All right. Is this clear for everybody in the back? Awesome. Okay. So to create a table, you're going to want to run the syntax create table, then the name of the table you want to create, as, and then after this is going to go a query. In principle, you could put any query you want in here. So I'm going to do select star. This means I'm going to select all the columns from this table here. Read CSV is a table function in DuckDB that's going to read this CSV file that we just downloaded. So I'm going to run this. There we go. It's going to return to me the count, how many rows it just loaded. In general, the syntax is create table name as my query. But if you've already created the table, which I just did, which I hope everybody just did if you're following along, you're going to want to use slightly different syntax. So that's going to be exercise 1. Try and recreate the table. So everybody take maybe like a few minutes and put up your yellow post-it note if you're ready. To create a new cell, you're going to want to click code, and then here I'm going to DQL. All right. right, I'm just going to continue since we're warming up here at 8 a.m. So I'm going to show you how to run and show the solution. So you want to uncomment this line here. I'm just using command slash or control slash on Windows. Here you go. So if you want to add any comments, by the way, at any time in your SQL statements, you know how in Python it's this hash symbol? In SQL it's 2 dashes. So here you see there's this comment tag here. Yeah, so this is our answer here. We want to run the exact same query that we ran before, except that now we use create or replace. So I will show you if I just run the same thing again, create table weather, it's going to throw an error, right? It's going to say, hey, the table with the name weather already exists because I just ran that earlier. So if I use create or replace table, now it's going to be happy, it just recreated it. All right. If you have any questions about it, put your post-it note on and we'll come walk up to you. All right, that was first exercise, warm up. I hope we're warm. All right, so next we want to actually be able to see what's in this table. Of course, you can run a query to see the contents of the table. What might actually be more helpful is to describe the table. So in the next cell, if you run that, it has this syntax describe weather, right? What it's going to do is it's going to show you which columns are in the table. So it's give you the column names and then the type. So we've got a station column, which is the name of the station, or the ID of the station, which is a var char, which is sort of like in a Python a string. The name, the latitude of the station, which is a floating point number or a double, the elevation, the date of the observation. So these are all weather stations, right? So they're all observing the weather. Then a number to indicate the precipitation, the maximum temperature, the minimum temperature, and the observed temperature. All right, so that's a helpful command you want to use when you are looking at some data. All right, so now, like I said, you can query the table. So this is the SQL command you want to use. So select star, again, it selects all of the columns from weather. We'll run this. It's going to give us a table here. This is basically output in pandas formats. That's familiar. So we've got all of those columns we just mentioned, and then it shows you the first and last rows of the table. So here, for example, we've got the station here, which is called Tacoma number 1. The latitude, longitude, elevation, date. So this was on January 1st, 2023. And it had some precipitation, and there was here, or between 38 and 47 degrees Fahrenheit. And then if we scroll all the way down, we've got some temperature data at the end of the year, 31st of December in Palmer, Washington. So we got our SQL hype guy. Wait.
Sorry, SQL hype guy here. You made it. You can get all the data you want with just that command. We're done. Don't worry, there's a lot more fun stuff. What I'd like you to do is, if you aren't quite here yet, please put up your non-yellow Post-it note on your laptop if you'd like some help. Thanks, everybody.
All right, so this is your first SQL query. Select star. Now let's do some cool stuff. Let's filter rows. Okay, so we all know this is what a table looks like. It's got rows and it's got columns. You can filter both ways. So we're going to start with filtering rows. So let's look at all the rows where the temperature is above 82 degrees Fahrenheit. And this in no way has anything to do that we're in a massive heat wave right now. Completely unrelated. So as you can see, there were only 8 measurements last year that were above 82. Somewhere in Tacoma, somewhere in Landsberg, somewhere in Moreau. All right. So as you can see, all of these are above 82. So here I can start playing around with this. I can put, let's see, what do we have here? Yeah, everything is right above it. I can put 75. Should get some more hits there. So what this does is it filters this where clause. It filters by a column value. So I can also do some Boolean logic in there. So I can select all the columns from weather where the precipitation was above 2.5. I think this is millimeters. Or the elevation is above 600. So now I'm going to get hits for both of those conditions. So here you see these precipitations are above. Then I've got one that has a precipitation below that value, but it has an elevation that's higher than 600. So yeah, so here you can start doing some fun stuff. If you want to do very complicated logic here, you're going to want to put things in parentheses. But typically, if you just have two statements that you're combining with and, you can do and as well here. Probably not get a lot of hits there. Oh, I got some hits. No? Yeah, got 2 hits here if you put and. Then you don't need any parentheses. All right, next exercise. I'm going to get the SQL hype guy out soon again. All right, let's filter all the rows where the station name is Tacoma number 1, Washington, US. So this exact string here. I should also mention, it's mentioned here in the text, strings are indicated with single quotes. So here, for example, my string value, like so, it's a single quotes, and column names are indicated with double quotes. So in here we have a really nice friendly table that doesn't have any spaces or special characters in the column names. So we don't need any quotes, but later on we will look at some data that has that. So yeah, don't use double quotes, use single quotes if you want to indicate a string. Let's take a few minutes. When you're done, put your yellow post-it note on the top of your laptop. Elena pointed out to me that hand raises are more effective than post-it notes, so if we're not actually coming up to you, just raise your hand. That's also fine. Or yell, that's also fine. So a reminder, because we're in a Python environment, if I'm going to run a SQL command in my Jupyter cell, I'm going to get an ugly error. It says invalid syntax, because this is SQL syntax, not Python syntax. So to transform this cell into a SQL cell, just put this %% DQL magic command on it, and we're all happy. This is not the answer, by the way. This is just me showing real quick. Do we need more time? Oh, we got a hand up over there, Elena.
Also, somebody discovered that selecting star from CSV without the CSV command works.
Oh, awesome. Yeah, that's a good point. You don't actually need the read CSV command. You can also just select star from a CSV path, which is awesome. All right, I'm gonna move on since we don't have a lot of time left, so I'm just gonna comment the answer. So, to filter the rows where the station name is Tacoma number 1, Washington, US, you want to do select star from table name, from weather, where name equals Tacoma number 1, Washington, US. So, I only need 1 equals symbol, not like in Python where I need 2. In SQL, I just need 1. So, let me just run that over here. Again, don't forget the magic command to transform our Python environment into a SQL environment. Great, so now I should get 365 entries, yeah, 1 for each day for Tacoma. All right, let's move on to the next. So now we did filtering by rows, let's filter by columns. So if you wanna pick the columns you want, so this is a pretty big table, right? As you can see, I gotta scroll to the right and to the left to see everything. Let's say I'm only interested in the name of the station, the date of the observation, the minimum and the maximum temperature. And what I do is I run select and then name, comma, date, comma, temperature min, etc. So I list all of the columns I want to see from the table. And this semicolon is optional, so you can or you don't have to use it, but it's officially the SQL syntax for the end of line. So if you want to add another line below here, for example, then you're going to want to use this semicolon. All right, there we go. So I've filtered on the column names, so vertical. So now it's only showing me the name, date, temperature, and the min and max temperatures. All right. So yeah, next exercise. Run describe on the weather table to inspect the column names, like we've done before. And try selecting a few new ones. So for example, select the name, date, elevation, precipitation, or the observed temperature columns. So just try and play around a bit with, with this statement over here. You can just go ahead and copy this into a new cell over here, and then start playing around with that, and just see, yeah, if you run into anything. I'll give you a couple minutes for that.
Throw in a small Easter egg. Most SQL dialects can't do this, but DuckDB SQL will allow you to have trailing commas. If you accidentally forget and put one right before the from, it won't yell at you, it'll still work. So that's your friendly SQL tip. Don't try that at home on another database, it will get very angry. You could try it here.
So Alex just mentioned the trailing commas. What if I told you you can just not do any select and just say from weather? I know, right? You'd think, no, this is wrong. This can't be right. But it is. It gives you all of it. It's basically the same as select star from weather. If you just do from weather, same thing. It's not standard SQL, correct. This is DuckDB hackery magic.
We're doing the typical like math teacher thing, teaching you the hard way, okay, and then the easy way after that. Sorry.
All right, everybody caught up? I see a lot of yellow Post-its. Cool, thank you. You can take them down again. So yeah, describe weather and select some columns and you're off to the races. All right, next exercise. Select the temperature max and temperature min columns and filter down to only see the rows where both of those values are under 60 and above 50. So we're just going to combine a little bit of the skills we just gained and write a query that selects a few columns, so filters by column, and then filters by row. So we're going to add a table that's both smaller in one dimension and the other. So give that a try. And don't hesitate to use trailing commas and be a rebel. All right, we're going to move on. So here we go. You want to select the two columns we talked about from the table we talked about, and then we've got just this logic statement over here, filtering by the maximum temperature above 50 and below, and temperature min above 50 and below 60. When you run that, you should get about 21 rows. All right, next. Now we're going to add a calculated column to our results. So SQL can let you do some basic math. So if you want to calculate the average of the max and min, what you're going to do is just, this is actually pretty similar to Python syntax. Temperature max plus temperature min in parentheses divided by 2, just like a calculator. Then, I don't know if I already introduced as. Well, we looked earlier was create table as syntax, right? Create table weather as Mike. So you can use as also to create an alias. So if I run this here, you see that the calculation I just did is going to be aliased or labeled as mean temperatures. This is the name of the column. So as you can see, it just calculates this for me. If I don't use as, it's still going to work, but my column name is going to have the literal equation in there, which is a little bit, that's where you need those double quotes that I talked about earlier. So we kind of want to avoid that, so we're gonna use a nice snake case name here, but but in principle you don't need it. So next exercise. Add a new calculated column called temperature range that gets the difference between temperature max and temperature min. So, again, don't forget about your DQL, but you can just get started and copy this and then edit it. So we get the range. So please put your yellow post-it notes up again if you're done. We'll check in again in a couple minutes. Got about 4 exercises left, so should be on schedule.
Small note, if you guys are running the %% DQL, you'll notice that if you have any commented out Python lines at the end, it will not run. So watch out for that. If you're going to do % DQL, just clear out your Python comments first. Sweet.
So it was pointed out to me I never finished my story about the animals. So there's a really cool setting in Colab here. It's under miscellaneous. You can turn off or on corgi mode, kitty mode, and crab mode. And I've turned them all on because I think it's cute. And then power level, I would not recommend this. It's a little distracting. But you can also turn on power level. Not like these crabs and cats are not distracting, but that's okay. All right. I see yellow post-it notes appear, so we're going to continue. So to get the difference, we're going to use this query over here. Select, again, you can use select star, or you can select some other columns, whatever you want. Temperature max minus temperature min as temperature range. Also, you've noticed, usually what we do as good math teachers, as Alex pointed out, all the SQL statements are in all caps, and the names, strings, etc. are in lower caps, or in case-sensitive caps. But if you just use lower caps, that will also work. It's up to you. It's kind of an old-timey thing that people did before there was syntax highlighting. All right. Okay, next exercise. We're going to do a little bit more of a calculation here. Create a new calculate column, the observed temperature in Celsius. So this is the conversion here. You want to subtract 32 from the Fahrenheit number and multiply by 5/9, and you'll get Celsius. So please go ahead and add that calculated column. All right, I'm going to speed things up a bit since we're nearing the end of the hour. But yeah, pretty much the same syntax as before, just now just a different equation. All right, we've got 2 more exercises left. So next we're going to use the order by clause. So as you saw before, we got the results back in some order. In this case, they're ordered by date. This is determined by the CSV file. So if you open the CSV file in an editor or Excel or something like that, you're going to see they're all ordered by date. So that's what SQL is going to return. But if you want to order it differently, for example, by precipitation, I can do that too by using the order by statement. So you're going to just have your regular old SQL query, select columns from weather, and then order by precipitation. Then you can specify whether you want descending or ascending. So dusk is going to be descending. So here I go from high precipitation to low. As you can see, it was the most rainy in Bremerton. If you want ascending, you see it was the least rainy in Tacoma last year on January 2nd. Well, I guess this may be not quite fair because there's a lot of zero measurements. There's a lot of places where, but anyway, that's how you do it. So yeah, please give that a try. Use the query you created in the previous exercise, just copy that over, and then order the rows by precipitation in ascending order. And then I'll go straight into the next exercise as well. You can do them both back to back. Get the station, name, date, temperature, observed, and precipitation, and then sort the table such that the row with the lowest temperature is at the top of the result table. So do ascending order. And give that a try. And when you're all done, we're going to start the break. So you don't have to put your Post-it notes up. You can just go and grab some coffee or tea. Again, just raise your hand or put up a Post-it note if you need a hand. Feel free to walk up here and inspect the duck pond, the duck tub if needed. And you can come up here and grab some stickers. We've got a few different stickers. We've got a limited number of DuckDB stickers. So grab them while they're hot. And then we've got some mother duck stickers and some stickers to show off that your laptop is faster than your data warehouse. And that the big data is dead, because it is. So, and some cute little duckies. So yeah, just take your time with the exercises, and we'll reconvene with section 2 at 9 a.m. Thanks, everybody.
Small note, if you copy the answer or the helpful text, it will give you a dash that is not a real dash, and it will not work. So you have to type the dash. We love fun character encodings. So there you go. It's the same in every language, isn't it? It's always like the weird quotes and
Where's your Google ID, right? I don't know, do we want to? Sure.
So we went into separate field next to the yes. Say yes one. He's just the sassiest stickers. You're so sassy.
Yeah, especially
Yeah. Okay.
Quick question, get Korean. Yeah.
Good job on the tutorial.
Thanks.
Thanks for having us.
Oh, yeah.
The most important question, where do we get the coordinated Dougie shirt?
These are on Amazon, man.
Ah,
There are
okay.
other people this crazy.
Okay, okay.
We did get them custom where we got our own little duck feet logo on
No
there.
way.
But,
Just snuck on there.
yeah, we actually buy a decent number of these.
we're out of these stickers. We have some more somewhere.
I don't know about that. Thank you.
Well, that's good to know that you've got plenty on hand.
Yes, we didn't bring any with us. What we usually do is like at a conference we have one of those like crane games.
Yeah, when
So you have to
one?
like go down and you have to like.
There's none?
I don't think we have any with us today. Thank you for asking.
Next time.
Next time, or Amazon.
Thank you.
Hey, Matthew.
I wish I had known this like 2 years ago, because I was like 2 years ago writing like
Oh, yeah.
like SQL statements with like parentheses, building them manually in Python. It was awful.
We've been there. Yeah, so if you want to run a SQL statement
You're
without...
on the mic.
Yeah, I know. I'm just in case anybody else has the same question. We need to add a good question. If you're not using Jupyter, but if you're using like Spider or something, you can use DuckDB. You can just run, I think, actually .sql directly.
That's what I found in the documentation.
Oh, you already found this. Okay. Yeah. So this also works. This is basically what the magic command does under the hood. Yeah.
So you can like build it up as just like a string.
That's right.
So,
And
but
just
you would have to use like .SQL for every statement.
You would, yeah. Or you can create a connection. So if you do con equals duckdb.connect, and here if you want a persistent database, for example, something like that, and then you can do con.sql, and then it will run the query on your database file, like if you want to, you know, create a table there. Yeah.
I wonder if it would be like to add those like magic commands to like Spider.
To Spider, yeah, that would be amazing.
Yeah. I think there.
All right, do you want to swap computers? There is a power cord up here. if you can just show the last two exercises of chapter 1 before you start.
Oh, great idea.
That would be awesome. Not
Yeah.
necessary, because the answer is right there, because we were halfway yesterday.
Oh, it's still a great idea.
I think this is my tea, right?
It is not mine. You are welcome to it. Okay.
But that water is yours, right?
The water is mine. Yeah. I could also do just, so we just make that my main display.
Yeah, mirroring usually works better than extending.
Okay.
But let's take a look at the actual. Let's see. Let's see what the actual iteration is. Oh, it says scaled. How about default for display? Did you try that?
No idea what that means.
Oh, presumably the model of the projector. So let's, we can change that to immediately change it. We might have to flag down some different name.
Okay. I might be able to zoom in. Just how do I even change the resolution though?
That should.
Oh, optimize for the other one. That'll do it.
Wait, what is it?
I changed and I said optimize for the other one.
There's usually a place where. Oh,
Is this what we want?
this is.
Is that all right? Sorry.
Oh wait, what is this? Preset. Preset. Yeah, I don't know.
Sorry, Glenn.
That's totally fine. Which are weird. Oh, one quick comment. We realized we forgot to enter an email and name field in the form. So if you already put in your guess for the duckies, please go back and edit your response and add your name and email address so we can actually contact you if you want. Sorry about that. I see there's only 2 people, though, who are affected. So please double check that if that was you, that you've entered your name and email. All right. We're going to go and get started on section 2 in just under a minute or so. Oh, you get to give out a lot to somebody. So you can figure out why and when. All right. I think we're all set. Let me make sure I get you the correct Colab notebook.
Thank you.
You're welcome.
All right. We got a lot of fun stuff coming up, so we're going to get rolling. Let's take a quick look back at the exercises we finished up right at the end of the last session. So we will take a quick look at what those answers were. So we wanted to order the rows by precipitation in ascending order. So the keyword there is order by precipitation ascending. It's a little bit interesting that it's after the column, but that's how it has to be. We had a good question in Slack. How do you do multiple columns? You can separate them by commas. So you could say precipitation ascending, comma, any other column I'd like, descending. You kind of mix and match. The other last exercise was looking at the station, name, date, temperature observed, and precipitation. And then we're sorting it so the lowest temperature is at the top. So that's ascending. And that is what that looks like here. Sorting order by the observed temperature ascending. All right, let's jump in. So we are going to turn it up to 11. This is the crash course part of the crash course. So here we go. So not only can you grab particular columns of data that you want, particular rows of data that you want, and do calculated expressions, you can do this across multiple different tables. And so that's what we're going to look at with joins, and that's what we're going to look at with subqueries. We're also going to look at doing a little bit of aggregation. Everything we've done so far has been row by row, but let's do some summaries. So we're going to start with group by. All right, so with this notebook, you do have to reinstall, and we will grab our new content here, and we will go ahead and create two tables this time. We're going to have a birds table and a ducks table. Shocking that we picked this example, but we love our ducks. What I'll also do is I'll run the summarize command. This is a DuckDB specific command. It's meant to mirror pandas, because that's part of the reason DuckDB exists, is because pandas is easier to use for a reason. That was a huge focus of why it exists, and databases did not have that level of focus when they were created 50 years ago. And so DuckDB is trying to meet in the middle and bring that back. So summarize, for example, will get you a lot of the summary statistics of your table. So not just what are my column names and types, but also some min and max values, how many unique values do we have, and it'll do some quantiles for you as well. All right, everybody in the new notebook, able to see the new tables? Anybody that isn't, raise your hand and folks will come around and help. Thank you, thank you. All right, so we're going to look at these couple new tables here. We've summarized them a little bit. We can see that their names have capital letters in there and underscores. What's nice is that the vast majority of SQL dialects are case insensitive with column names. So you can refer to them just with snake case, and that's the best practice. If you're naming columns in SQL, anyone else who has to consume your data will be your friend if you use snake case. All right, so we've looked at those tables. The next thing is that we want to create a new table from it. So this is a throwback to the last session. We want to go ahead and create a table based on a CSV file. So if you go ahead and write that statement, it'll look a little bit familiar. Just take a moment to look at that. And we have a second exercise at the same time, doing the same thing with another table. So just create two new tables there so that that syntax sticks in your brain. One thing to note, this read CSV concept, it's designed to look like pandas. Not all databases have this exact syntax. That's one fun thing about SQL. Again, it's structured query language, not standard query language. So this is a DuckDB specific thing, way to grab your data and load it real fast. The vast majority of databases have a way to do this, loading a CSV, pretty universal. DuckDB also supports Parquet and JSON. Those are a little less common, but CSV, as we know, gets the job done. If you're done, throw your Post-it note on your laptop for me. All right, so let's jump into aggregate functions. So now we are going to be changing and manipulating the shape of our table. We're no longer just filtering the columns or filtering the rows, we're actually adjusting the shape of what's coming back out. So in this case, we're looking to start with just running aggregate functions. So the expressions that we did before, multiply, divide, add, those are functions under the hood. They're just operators instead. The plus sign gets rewritten to, a plus function of this plus this. So we were running functions before. They just looked like operators. And they were all running row by row. Every single row was having that executed separately, and you get a separate result for every row. With an aggregate function, these results go across multiple rows. So if I want the minimum value, I want the minimum value of a whole column. It doesn't really help to have a minimum value of an individual row. Although that's possible, we're not going to talk about that today. We only have so many hours. So in this case, we're going to select the minimum beak width and the maximum beak width, separated by a comma, from a table. And what this is going to give us is a one-row result. So much, much smaller than our full table, of course, which had 90,000 rows or so, because it's doing an aggregation. It's looking across all the rows and summarizing it into one. So it's aggregating. So that's somewhat useful. Sometimes we do want to see the result of an aggregate across an entire table, but more frequently we want to aggregate by some other dimension. So that's what we're going to do next. That's with the group by clause. So to do a group by, to do an aggregate, you really need two things. You need a group by clause and you need the aggregate functions we just talked about. So in this case, what we want to do is we want to say not just overall, what's the, the min or max of the overall data set. Let's look at it min max by, grouped by a particular other column. In this case, we're going to look by the species name. So what this is basically saying is for every species, show me the average. Beak width, beak depth, and the beak length. And so you can see that's what we have. We have dramatically reduced the number of rows. We're looking at only 8,000 instead of 90,000 because it's summarized. That's kind of how we're doing aggregations and doing summaries. So how would we kind of expand on this? Well, you can do this with multiple different columns. So if I wanted to do species common name, I could also add another column, and it'll look at all the combinations of those columns that exist in your data. And you would just add that to your select clause and to your group by clause. So this is not just limited to one column, it's as many as you'd like. And you can also do as many of these columns wrapped in aggregate functions as you'd like as well. I believe we've got, one more example, and then we're going to go ahead and look at an exercise. So in this case, we want to look at multiple different columns. And that's exactly what we were talking about. So instead of looking just at the species, we want to say for every combination that exists in the data of country and source, I want to figure out what's the biggest bird in that area. How big does it get? So I've got my select statement, and I also update my group by to go ahead and decide at what level I'm aggregating. I have to show this because it's too fun. You might notice that you're repeating yourself with SQL. Unfortunately, that is a fact of life in almost every SQL dialect that you're going to have. You're going to need in your select clause and your group by clause the same kind of dimension columns, if you think about it dimensionally. The ones that you aren't aggregating, your non-aggregate columns. DuckDB has realized this, and we figured out, hey, why not just use a keyword and do that for you? So you can say group by all. It's going to do the exact same operation, and it's going to figure out, okay, it's sort of like the star, where we know that star means all columns. Well, here the all keyword means all non-aggregated columns. So wing length, for example, gets ignored because we want to aggregate that. We don't want a separate row for every length. We want the summary, the max, and it'll just automatically create that for you. Other databases have adopted this. So Snowflake, for example, supports this as well. I think BigQuery does too. So it's catching on. See, a 50-year-old language still can dance, or waddle, as it were. All right, the jokes don't get better. So exercises, let's take a look at a couple. Let's do these two back to back, and we'll come around and answer questions. So run a query that gets the average beak length, wing length, and tail length across the entire data set. So all the birds. And then the next exercise, run a query that finds the average tail length by species common name and by country WRI. So we're going to do, I won't give too many hints, but we've seen these before. All right, raise your hand if you have questions. Maybe a quick poll while you're working. How many folks have done aggregates in a data frame library like pandas or polars? Awesome. you'll notice a little bit of a difference. There's no real such thing as an index column in SQL. So typically with a group by or an aggregate that you're doing in pandas, you're going to have an index, sometimes a multi-level index, something like that, that has those non-aggregating columns in it. In SQL, those are going to be just in your actual result table, and you'll see the values repeated instead of the values kind of in a tree structure. But it's very similar. Just think of that index being, it's as if you called .reset _ index right after you did your pandas aggregate. Cool deal. And when you are done, toss up that Post-it note. It helps us. Do we still need more time? Anybody want some more time? All right, we're rolling onward. What would it look like if we want to aggregate across the entire data set? Well, we don't even need a group by clause. We just grab some averages, and those will summarize up down to just a single row of data that will summarize our entire data set. So select average of beak length, average of wing length, and average of tail length. And SQL uses AVG, because it's an old school language, instead of average or mean, but that's where we are. Let's take a look at the, as you may have guessed, the group by example. In this case, looks like I could have improved the solution, so we're going to do it live because that's not the best solution. All right. %% DQL. So, who can tell me what I did wrong or not optimal? Yes. I did not put my group by columns in my select clause. 100% right. Thank you. If you'd like a mug, you can have a mug. All right. Thank you very much. So see, there's benefits to answering my questions. So this makes it a lot more useful, right? So let's say, so we didn't even talk about what a comment is in SQL, but -- is a comment, so you can tell it to ignore those lines. So if we tell it to ignore those lines, all we have are these average numbers, but no context. What the heck is this average about? Well, you need to have those columns in both places, in your group by and in your select statement, so you can figure out, okay, what is that average even referring to? All right. So let's do some fun stuff. How about some percentiles? So SQL doesn't just have min, max, and average. Many databases have a wide variety of functions available, including statistical functions. So in this case, we want to go ahead and do a quantile of a particular column. And in this case, we are looking at the whole data set, so we don't need a group by clause. And so we want the quantile continuous of a particular value, and our second parameter to this aggregate function is what percentile we'd like. So across all birds, the 95th percentile beak length is 59 some arbitrary unit, probably centimeter. So giant. Yeah, my ability to visualize metric is 0, so do what I can. Let's do a quick couple of exercises here with some percentiles so we can get a feel for some handy functions. So let's do a query that gets the 95th percentile and the 99th percentile of the beak length. And then we're going to do another example where we get the 99th percentile of our wing length, but we want to actually know this by the species, not for the whole data set. So there's your hint. Raise your hand with questions as you have them. All right, who would like some additional time? All right, we'll give it another minute. We have a spare minute. Yeah, Joyce, half an hour. We're doing it. And subqueries. We're doing it. Okay. All right, let's roll. Let's take a quick look at our solutions. So if I want the 95th percentile and the 99th across the whole data set, I'm going to call this function 2 different times, providing 2 different columns as my output, and I'll pull it from the birds table. I don't need a group by. Now on the next one, I'm going to add a group by, and I'm going to add my column into my select clause as well. So for every species, I want to know what the 99th percentile is for each species. All right, so now we get to some of the fun stuff. So looking at joins. So how many folks have done a join or a merge statement in a data frame library, like pandas or polars? Awesome. You have seen this movie before. Are there any folks that are Excel users? They've done VLOOKUPs in the past. Oh, I get to raise my hand for that. All right, great. Well, both of those are very good analogies here. So we're gonna go full speed. So within SQL, there's a few different ways to join, and pandas follows very similar syntax in the I believe it's the how parameter for your join statement. So this allows you to horizontally combine 2 different tables. There's also a way to vertically combine, but we only have so much time. But we're going to horizontally combine with a join. So it's very useful if you want to pull data from different tables. So the example here is we've got a data set on birds, but we have another data set on ducks, where for the duck species, we have some extra information. So for every duck species, we want to go look up a little bit more information. So it's a little bit non-standard. We're joining on a string. That's OK. The kind of quintessential example is, let's say you've got your sales data, your revenue data. And instead of on every row of sales data, including all the information about your customer, customer name, customer location, how long they've been a customer, you might just keep an ID there, customer ID number. And then you might have a separate table that has the customer ID and then all the details about it on that row. But if you want to connect those together, you do a join, and it's going to be a lookup on that ID number. So in our case, we're going to do our lookup on the species name. That's our unique value in the ducks data set that we're connecting to. So we're going to do a select statement, and we'll see a few things have changed here. Let's jump to the from clause here. We do have from birds, and we're doing an inner join. An inner join means that we only want to see rows that match in both tables. So an inner join requires us to have a match, and if there isn't a match, we actually remove that from our data set. We don't see it anymore. So it's only matches. And so we're going to do from birds, inner join ducks, and we'll get back to the top here in a minute. And then we have this on statement, this on keyword. And this basically defines, how do I connect these? What is the string that ties them together? And in this case, it's going to be the species common name, and it's actually named something different in the ducks table. So these column names do not have to match. You basically just map out this column matches that column. What we've been doing as well, something we haven't been doing before, is we've been specifying our columns with table name dot the column. And we haven't needed that because we've been in the same table up until now. So we could have been this whole time saying birds dot this, birds dot that, but we didn't need to. But now that we have 2, it's really good practice to always label where your columns are coming from. Trust me, future you will thank you. So always have birds dot or ducks dot for good practice. So in this case, we want a couple of columns from birds, and we want to tack on a little bit of extra information whenever we have a duck. We happen to know who discovered that duck, which is pretty neat. So Linnaeus, great job. Egyptian goose there. Not sure how to pronounce that one either. So we've got that extra information. But important to note, how many rows are we looking at? Remember how big our original data set was? 90,000. So this is acting like a filter and a lookup because it's an inner join. So inner join is kind of doing 2 things at once. So that's kind of our step-by-step explanation, is talking a lot about what I've been mentioning. But I want to talk about some gotchas. You'll notice the gotchas section is long. Joins are full of gotchas. Same in pandas. It's just sort of the way you have to combine tables. There's a lot of ways to do it. So when you're doing an inner join, we only show matching data. So be careful. That can really filter your rows. So most of the time, when you're doing a join, you're taking that lookup ID number, like say customer ID, and you're connecting it to your customer table. And most of the time you expect for every customer ID to have a customer ID in that other table. And usually you're right, and you can use inner joins everywhere. But if you're wrong, your data will silently disappear. And that's not great. So we'll see in a minute a good way to avoid some of that. But be careful. Also, you can get multiples. Let's say somebody accidentally added another entry into that customer ID table. Or in our case, in the duck table, let's see 2 people are fighting over who discovered it. They both put their name in the list, right? 2 authors to the same duck species. Well, we would start to get duplicates when you join. Because join looks for all matches, not just one match. So if you're coming from an Excel mindset, like I was when I learned SQL, that's very different from a VLOOKUP. A VLOOKUP is going to find the first thing that it sees in the other table, whereas a join is going to find multiple. But this is how pandas behaves, this is how polars behave, so you guys might have seen it before. Also note, inner is an optional keyword. You can just say join. That's the default type is an inner join. So if you see table, join table, that's actually an inner join under the hood. And lastly, this is possible to do with multiple columns. So you don't have to just join, species to species. Let's say you had species and another, subspecies name, right? You could map that. So the way I like to think about it is, what if I had, first name and last name? I want both of those to match when I join. You can specify that in your join clause with an and in between, just like we were seeing in our where clause. So let's do some examples. And a quick aside, so I learned I learned SQL with a book called SQL for Dummies, and I had to reread the joins chapter 4 times. So it's worth practice. Worked out. I had to do a lot of practice. So we do recommend taking a look at these exercises. So we want to run a query that gets the name, the beak length, the wing length, and the tail length of all birds that are ducks. And I think, hey, that doesn't sound like a join. Where's the connecting together? Well, remember, a join can be a filter, and that's how we're using it here. The next example that we'll do at the same time is, let's go ahead and do something similar. Well, we are also going to filter for birds that are ducks, but we're also going to go ahead and aggregate. So we're mixing concepts together. You're going to connect it together with a join to do that filtering, and then you're going to do an aggregation. So we'll take a look at that. And with this one, takes some practice, so please put those stickies up so I know when folks are ready. Yes. I'll also mention as well, there is a Slack channel for this tutorial in the SciPy Slack. So if you have a higher level question, or just kind of some background question, something that you don't need an urgent answer on, feel free to post in there. We will answer all your questions there. But you can also just come find us during any break. Who would like some additional time? All right, you have that. All right, we got a couple other fun things to look at, so let's jump right in. All right, the first one, we were looking to do some filtering with our join. So in this case, we are using that inner join. We could have skipped that inner keyword if we'd like. And so we're doing, I always start with the from clause. That's why I love the from first option in DuckDB, but that's mentally where I start. You know, where the heck is my data? And then after that, I go do my select statement after. So I want it from birds, inner join my ducks, and I want to join on the same criteria. And I'm going to go ahead and grab a different set of columns. And you'll see in this case, we didn't grab any columns from ducks. You don't have to. But that filtering action is going to happen because you force that match with the inner join. So we're really using a join like a filter. The next one is a little more complicated, but that's the fun. So because we're doing an aggregation, you want to think, aggregate functions, your averages, your mins, your maxes. And in the question, we wanted to specifically look at it by the species. So we're going to need a group by. So we've got our same join criteria here. This is acting like a filter. And then we're going to pull in just our species common name as a column, and we will do some aggregate functions around the various metrics that we want about it. So for every species, I would like these 3 averages. And as a part of that, I need a group by. I can group by birds.speciesCommonName, and then order by the same thing. So you can kind of do it all in one shot. That's kind of the blessing and the curse of SQL. You can do a whole lot in one statement. So there is a fine balance. We're going to see in the very, very next section how to split things apart. But it's a design decision a little bit about how much you want to do within each individual step. Typically, I like to do things fairly separately. And I like to do a lot of checking about, did I drop any rows I didn't expect? So I do a whole lot of double checking how many rows I've got at every single step. And we'll see as we go through some good ways to do that. All right. So the first good way to do that is the left outer join. So instead of an inner join, this is an outer join. So we allow, we don't force matches to have to happen. We will also bring in rows even when the match doesn't happen. So we will keep all of the rows from the left table. And then we'll optionally add content from the right table if it exists. So this is the closest match to an Excel VLOOKUP, index match. It's keeping that left around. And similarly to inner join, the outer is optional. A left join is the same thing as a left outer join. And we will see some gotchas very soon. So whenever things don't match, it's going to have the SQL equivalent of Python's none, the missing indicator. In SQL, we call that null. And it's basically just a missing value. And it acts a lot like Python's none. Nothing is equal to it. Nothing equals none. Nothing equals null. So you have to use that same is keyword and not the equal sign when you're working with null. So it's a very common gotcha, but you guys already know how that works. You're ahead of the game. So let's take a quick look at a left join. So this query looks almost identical to what we did before, but we switched inner for left. So what is the result of this? Well, the result of this is I keep all of my original rows. I still have 90,000 rows. However, some cases I don't know who the author is. They're not a duck discoverer. In other cases, they are. So this is showing up as none because the %% magic is returning it as a pandas data frame. That's why it's in our Python none flavor. If this were pure SQL, you would see the word null there. instead. They are functionally the same. If you have a pandas data frame you want to load into DuckDB, which is possible, it will translate none into null for you, and back and forth. So that is left join. So this is typically the join I use first. If I'm joining two data sets I haven't seen before, I have no idea if they're going to match or not. So I always start with left join. And once you're confident that your data is clean, swap that out and remove that left. So gotchas. There's always gotchas with joins. You may not always have exactly the same number of rows in a left join because of duplicates. So once again, if we had two people claiming that they had found the same duck and you join them together, even with a left join, you will still get multiple matches. And so you can end up with more rows with a left join than when you started. Same with an inner join. So you got to be careful, and I think that's why I do recommend starting with that left join, and that quick check is, do I have the same number of rows as before? And if you don't, the culprit is duplicates. Another case where that can happen is if you have a where clause, which we're going to see in our next example. So obviously, that's the same idea of SQL doing a bunch in one statement. It's not just a join. You can join and then filter on it. So if you have that where clause, it's also going to be reducing your rows. So let's do an example. So let's modify the left join query above, and we want to look at only rows that are not ducks, which is crazy for me to say wearing this shirt. But we want the non-duck birds. And I even have a hint here, which we talked about. If you want to look at a null value, you can't use that equal sign. You got to use the is keyword, just like in Python. Who would like some additional time? All right, we'll do another minute. In the meantime, I will mention that this has a very fancy name in SQL. This is called an anti-join. The idea is look for things that don't match. So you can use the fancy keyword anti-join if you'd like, but I wouldn't. It's one more thing you have to remember. Just if you learn how the is keyword works, if you learn the where clause, you're already good. But you get to call it a fancy name. Go on one additional very brief rant. If you look up SQL join diagrams on the internet, you're going to get like things that have like 6 different flavors of joins, and one of them is an anti-join. Don't worry about it. All you need to know are inner join, left join, and a union statement, which we aren't covering today, but it's a vertical stack. So if you look at those diagrams, inner and left, that'll do you for probably a decade. Does for me. All right, well, we've got some more fun coming with subqueries, so let's take a look at our answer here. So in this case, we are using our left join. We're grabbing the same columns in our select statement, but we added a where clause where name is null. So you could have left off the ducks because the there's not a name column. Is there a name column? I think there's a name in both places. No, it's just in ducks. So you didn't have to say ducks dot, but it's good practice. And you're saying is null. So null is a keyword, just like is, so you don't wrap it in single quotes like a string. You actually want it to be the keyword null. So it's just going to be null with no quotes. You could name a column null and wrap it in double quotes, but please don't do that. All right. It's a pretty deep SQL joke. Sorry, folks. All right, so those are joins. Now you can connect data sets all over the place. You can connect them on one column, multiple columns, all different ways. So you can pull all your data together. However, so far we've done everything in one big statement. We're doing it kind of all at once. Well, SQL in the wild gets to be pretty crazy. I've seen 2,000-line SQL statements. How the heck could you do that with just this one set of building blocks we have so far? Well, the way we do that are with subqueries. It's nesting. It's a way we can do multiple queries chained together. We're going to look at two different ways of doing it, subqueries, and then something called the with clause, or a common table expression. They're essentially the same thing. So we're doing the typical math teacher approach. We're showing you the hard way first, and we'll show you the easy way second. But we're going to start with subqueries. So there are three different types of subqueries, because there are three different things you can look at, three different levels of detail, three dimensions in SQL. You've got an individual cell, you've got an entire column, and you have a whole table. And they'll behave just a little bit differently, but they're pretty similar. So a subquery can return either one exact value, show me the maximum wingspan of the whole data set. Or it can have a whole column, grab me all of the wingspans. Or it can be just a pre-processing step of your whole table of just, okay, let's do that join up front and filter down to just ducks, and we'll just do the join first and get the whole table back. So you have those three different types of subqueries. So in this example, what we want to do is we want to have our subquery in our where clause. So we're going to use a subquery to filter down exactly which rows that we care about. And what we care about are the exceptional birds, the most Pinocchio-like, the ones with the longest beaks. So what we're going to do is we're going to have this subquery here. And it's wrapped inside of parentheses, and it's another select statement. And in this case, our select statement is returning one value. There is no group by, so we're not going to aggregate up multiple things, and we have an aggregate function, quantile. So we're looking across the whole data set, give me the 99th percentile. So another thing that I very commonly like to do is I will just run just the subquery first. So if you guys are ahead of the game, you can go ahead and just run that by itself in its own cell, and we'll see what that says. So like we said, we just got one value back, and it's summarizing that whole column of the data. And what we're going to do is use it in the where clause. So we have a greater than here. We want to say, I want to look at all the birds that have a 99th percentile or above beak length. And I'm ordering it in descending order so I can see the giant ones. So we're pulling an ID here. A couple of the same type have really, really big beaks. So that's one example of a subquery. And we're summarizing just down to one individual value. Now, it might not feel very modular, but we'll get there. Hang in there with me. Math teacher style. Okay, so let's do a couple examples with that, because you can do quite a lot just with those subqueries already. So find all the duck species, so all the ducks that have a wing length that's larger than the 99th percentile. And then, can you find any that have both a wing length and a beak length larger than the 95th percentile? So we're going to do multiple. And there's an extra credit one. This one is combining together with the aggregations that we learned previously. So instead of individual ducks, find the duck species, the species common names, that on average have a measured beak size that's larger. So I fully expect, unless you've done SQL before, don't worry about this one. This one is in there for the folks that already know everything we talked about so far. So we'll probably just do one more minute here, and if If you want to do that extra credit, we'll probably save that for the break. So just another minute or so. All right, let's go ahead and have a look. So let's find the duck species, so all the ducks, that have a wing length larger than the 99th percentile. In this case, we're grabbing just a couple columns. We could have grabbed select star if you wanted. You can also do birds.star if you just want all of the columns from a particular table. If you do just a regular star, it'll grab all the values from all the tables that you've got joined. So you could do birds.star if you'd like. But we'll grab a couple, and we'll do our inner join to do our filter. And then we're also going to filter down on the wing length. And we will do the same thing, same kind of quantile here, but we're looking at wing length instead of the column we looked at before. It's mostly muscle memory. Practice digging into it, making some changes. So this one is looking at 2 criteria. And we widened it out to the 95th percentile because we needed to find some rows. So in this case, we have much the same at the top. We added in an extra column here so we can kind of see our output. We've got our join. And then our where clause has a little bit more to it. We're going to look at our wing length with a subquery. And we're going to look at our beak length with a subquery. So in SQL, some things you separate with commas, other things you separate with and. The way to remember that is your where clause is where that and is. It's really that Boolean logic idea of you have to have both of these be true at the same time. There's also an option where you can use the word or. So that's why we don't use commas, is because we need to know, do you want them to both match or match any and have that or idea. So and is always in your where clause. Commas are basically everywhere else. All right, extra credit. We'll cover that later. So we looked at subqueries a little bit, but we already saw an example where they look very, very similar to one another. And we can imagine a case where we want to reuse it. We want it to be a little bit modular. Maybe we want our code to be dry. Don't repeat yourself. Turns out it's pretty hard in SQL to totally not repeat yourself, but one good step is the with clause. So the with clause is also called a common table expression, or a CTE. So common kind of meaning the reusable meaning of the word common. It allows you to define a select statement that you can then refer to elsewhere in your query. So you can use that to, it's a common table expression though, so we're not using it for like a single value. Well, we can, but it's going to be returned essentially as a table. And you're going to use it in the from clause elsewhere. So let's look at an example. In this case, we want to go ahead and find the individual ducks that have a beak length above the 99th percentile. So in this with clause, we can actually break these steps up. So what we've been doing is we've been doing the join at the same time. So here we can actually kind of pre-process that ahead of time. And just with our duck beaks as this result. So this is our with block here, very much like a subquery. But it's going to have the name that we're going to refer to it later as, and then the actual subquery. So the subquery you don't have to give a name, but a with clause you do, because you need to refer back to it. You're kind of assigning it to a variable. And then we'll have another variable here, our beak length, and we will be able to use those here and do an inner join. So in this case, we instead of doing an where clause, where you say where this is greater than that, we're actually using the join to do the filtering. So where clause and join, you can in some ways use either at times. The previous version of SQL, way back in, I think 92 standard, didn't even have a join keyword. So if you see a query with multiple tables without a join, tell somebody to join the right decade, but you'll see it. It's out there. So in this case, we're going to use our join like a filter. And like we said before, you can do quite a lot of different ways to do that matching criteria. In this case, we're doing it as a greater than. And this is an area where SQL has a lot of flexibility, and not a lot of other ways of doing joins and other libraries implement the full flexibility here. But I could do multiple criteria. I could match on a column and have a greater than. I could match on 15 columns and a greater than. There's just many, many combinations of how you connect these data sets together. So we're using it like a filter. All right, so we've got a couple examples here, and then we have a break. So we'll go ahead and give maybe 4 minutes or so for the examples, and then we will jump into the break. I'm actually going to do one more example just because I think we skipped the simplest case, and I don't want to do that. So the simplest possible subquery that you could do is you can wrap things in another select. So here, I've done a subquery that doesn't really add any value. But what I've done is instead of selecting from a table, I select from a subquery. And so I've just kind of replaced it out. I can also give it a name. Technically, I could say, as my subquery. That will work. Most of the time, you'll see people skip the as here. Just give it a name. So this is kind of a simple way of doing a subquery. Well, these can get pretty nested and pretty gnarly. That's part of the benefit of the with clause is you can do it step by step instead of deeply nested. So let's rewrite this as a with statement. What we can do instead is say with, and let's give it a name. We'll give it my common table expression as open paren, and I'll grab this subquery here. And then instead of having to wrap it and nest it, then I can just say from my common table expression. Okay, same result. But this allows it to not be nested. I can reuse it multiple times if I need to reuse it multiple times, and it's a lot cleaner. So it's much better for future us if we use that with clause. You can also chain these together. We saw that in one example. That's another case where we had it separated by a comma. So you can chain these together and kind of iteratively build up. This is another way where instead of doing everything all in one shot, you can iteratively build up your SQL queries. So now let's jump into the practice. So here we want to find the duck species that have an average wing length larger than the 95th percentile of all duck species. So this is a tricky question. The duck species, not the individual ducks. And we want them to have an average wingspan larger than the 95th percentile. So we can't compare them row by row anymore until we've already aggregated it. So we should look at this and think, okay, step 1, aggregate. Step 2, filter. And when you have those multiple steps, it's really nice to do it in a with statement. So your first with is going to do that aggregation. Your next part of it is going to do the filtering. In the next example, what about duck species that have both a wing length or, actually that word both is confusing, that have a wing length or a beak length larger than the 95th percentile? So we're going to have some practice with that or instead of the and. So we've got 10 minutes or so. Feel free to go ahead and take a look and dig into the exercise and then have a quick break. Grab some more coffee. See you guys back at 10. And please raise your hands with questions. Happy to come around and chat. Answering questions. I'm good. I guess my coffee ice cold. And don't forget, if you want to go crazy, there's that extra credit question from earlier in the section. But you should also take a break. We got more fun coming up soon. We're going to mix and match Python and SQL in the next session. do a good job where, because DuckDB is a columnar database instead of row-based, it tends to be about 100 times faster than SQL Server for analytical stuff. So if you're dealing with anything over 1 million rows, it's going to be 100 times faster in DuckDB. Unless you use the columnar index in SQL Server, then it's only 10 times faster in DuckDB. But it's night and day. You're going to love it.
Well, I love the big web search.
Oh, it's not the same thing. Don't get me wrong. I hear you.
What I do on my home, what I do on my work computer, what we do on the server.
Yeah. Excellent question. Yeah, let's take, yeah. Sure. We'll do 5 more minutes. So if you've got questions, come on up. We'll chat. We still have a lot more stickers. Get some for your buddies that didn't come here. Hey, please. Well, they owe you, man. Cheers. Wonderful. I might have some more. Do you want me to look? That would be good. Yeah, that's all right. Sure. I think it did help. That was a really good idea. All right, anybody got any questions before we get rolling again? We got another minute or so. Just raise your hand. We have an excellent question from the audience. So as we jump back in, that's mug-worthy question. Great question. So the question is, we write our SQL in a certain order, but what order does it actually execute in? When I write a where clause, when does that filter happen? Is it before or after the join happens? Well, SQL is a declarative language. What you're saying is what I want my result to look like, not exactly how it's processed and how it gets there. You know, when we did a join, we didn't say, do I want to do a hash join or a nested loop join? SQL does that under the hood. It picks the right one. Similarly with the where clause, actually sometimes it's done before the join and other times it's done after, based on what's more efficient to be done in the engine. But no matter what, the answer will be the same. It will only filter where it's a legal move to do that. It's not going to accidentally filter in the wrong spot. But you can very much think of when you write a SQL statement, there's a separate step where it optimizes and it chooses the exact order to run things in. So if you have like 2 giant tables you're joining and you have a where clause that filters down one of your giant tables to like 10 rows, it's going to do that filter first before it even joins. That's part of the beauty of SQL. In a data frame world, which, you know, I've lived in the data frame world, there's a lot of really awesome stuff you can do. But frequently you're going to grab those 2 whole data frames first before you then filter. It's much more efficient if you do the filtering first before you even read it off of disk into memory. You filter it at the very, very first step. And SQL is very good at doing that automatically where you don't have to worry about it. So 10 out of 10, mug-worthy question. Thank you. If you guys have more like that, throw them in the Slack. We've got at least one more mug. All right. Thank you guys for being here. Thank you for hanging in there. We're going to look at our answers from section 2, and we're jumping into section 3, mixing and matching Python and SQL. So our answers, we were looking at, the question prompt was find the duck species that has an average wing length larger than the 95th percentile of all duck species. So it's a duck species, so we've got to filter to ducks, and we want an average wing length. So that says to me I need to do a join, an inner join, and I need to do a group by. And to keep it organized, we're going to use a with statement for that. And we're going to say our duck wings. Our duck wings, we're grabbing our species common name in our select and our group by, and we want the average for each of those. And by the way, we've filtered down to just ducks by doing that inner join instead of a left join. So now we have this result, duck wings. We could say select star from duck wings in our next step and just use that. But what we want to do is some further processing. So we're going to do another with block here. And we're going to get the 99th percentile. And in this case, we still care about ducks, but we want to look across the whole data set, not just, not grouped by species. We want to find the exceptional species. So the final step, we put it together. We take our duck wings, this is our species average wing length, and then we combine it with our 99th percentile, the full data set, and we do another filter operation. And we're doing that greater than in the join again. That's a yes. We what are the hard things in programming? Off by 1 errors in naming things. So this is named 99, but it says 95 right here, so it's actually 95. Sorry about that. Thank you, Quinn. So yep, you're doing the join there, and we're secretly giving you the 95th percentile instead. So if we were to run this, we will see there are 7 ducks that match that illustrious criteria of being in the 99th percentile of wing length on average. So how'd we do on that? Did we get it? Did we look at the answer? How many folks did it without looking at the answer at all? How many folks looked at the answer and said, okay, I figured out how you got there? Cool. Thanks for hanging in. All right, the next one. We're looking at an OR clause here. So this is, again, using the OR keyword in the where clause, so we can match one or the other criteria. So here, we're going to go ahead and do our trick here again with the aggregation. And we're looking at the species level. And we want to grab 2 columns for aggregate metrics this time, wing length and beak length. And then we could do this in 2 separate steps if we wanted. But in this case, I realized that the granularity is the same. We're looking across the whole data set. So I just added 2 columns here, our top wing and our top beak. And so what we're doing, this is not actually doing an OR, is it? No, it is. Okay, it's got it in here. Yep. So we are doing a pretty interesting join criteria here. Usually you're joining multiple columns, you're doing an AND, but in this case we're doing an OR. We're allowing multiple ways for it to match, and either OR will allow it to match. This is what happens when you write SQL queries late in the evening last night. You get really fun join criteria. There are many, many ways to do this. We could have done this in multiple different steps. We could have had a separate one for wing length, separate one for beak length. That would probably be a little bit more logical. We could also have done it in our where clause instead of our join. We could have said where the average is greater than the result of this. So there's also ways to do that. It's very much Lego blocks. You can kind of build it in the way that you'd like, and we are just showing you one way to assemble the Legos today. And hopefully, giving you the blocks so you can run with it. Any questions on this example before we move on to Python land? All right, thanks everybody. So if you wouldn't mind heading back to that motherduck.com/SciPy and going back to your overall Jupyter book here, we're going to look in section 3, combining SQL and Python. So go ahead and kick off the first couple steps. We're going to re-pip install, we're going to re-wget, grab some more data there. And what we're going to do now is look at, we're turning off the easy mode a little bit. We're not using %% DQL anymore. This is more like if you wanted to actually run this in a script in a .py file, here's the steps to do it. So if I wanted to use DuckDB, instead of doing the load extension of the DuckDB magic, we're going to actually import DuckDB, and we're going to use duckdb.execute. So we could have done here a duckdb.connect, but in this case, we're using the default connection, which is just in memory. So we're doing the simplest possible way here, duckdb.execute. So it's going to be in memory. It's following the Python database API spec. So .execute is standard across a lot of databases. So ODBC, other ways of doing it are going to have that .execute method. We're going to put our SQL statement inside of a string. You can wrap that in kind of whatever quotes you want. My typical go-to in SQL is to actually use the multi-line string. So that way I can format it however I want inside of Python. So I recommend the 3 double quotes or 3 single quotes around it. So you can do as many new lines as you want. So this still works if you want to do that. And then we're going to also follow the database API spec, and we're going to do .fetchAll. And that's going to grab all of our results. It'll be a list of tuples. And it's not super clean because it doesn't actually show our column names here. So there are other methods on the execute where you can grab the columns, so you kind of build back up the final result. Most wrappers are going to do that for you, where you can just kind of get a data frame back, and DuckDB is no exception. We'll see that in a minute. So here, instead of .execute, you can also say .SQL. There's a lot of additional methods on top of .SQL. We've overloaded it with a lot of other cool functions. But it follows the same pattern as execute. It's functionally the same when you do that fetch all. So I think the fun really begins when you start to mix and match data frames. So how many folks are pandas users at the moment? How about polars? How many folks use NumPy? How about IBIS? Okay, very cool. Lots of fun things. Other data frames I missed? Anyone using Daft or? Okay, there are others. There's lots of fun ones. That's great. So pandas is very popular. We have some other ones we interface with also. So part of the reason DuckDB exists is because Hannes Mühlhausen and Mark Rosfeldt, who created it, felt that databases were too hard. People were not using them because pandas was faster to get the job done. And it was much more effective because it turns out your time is worth a lot. Your time is incredibly valuable. So they went on a mission to take a database and make it as easy to use as a data frame. And part of that is making it work perfectly back and forth with data frames. So in this case, we're going to output a data frame instead of outputting a list of tuples. And it's as simple as putting .df at the end. And that's going to return as a pandas data frame. That's actually what's been happening behind the scenes all the time with that DuckDB magic. It's just using the .df method at the end and showing it back to you as a pandas data frame. However, not only that, you can actually read pandas data frames directly with DuckDB, pretending that they're a SQL table. And this is great for if you want to do a little bit of work in Pandas, a little bit of work in SQL, and go back and forth. Or if you just want to exercise your SQL chops this week, and you want to go ahead and write some SQL instead of what you'd usually do in Pandas. It's seamless. So we're going to go and import Pandas. In this case, we're going to go ahead and do our read CSV with Pandas. And we're going to do duckdb.sql, select star from ducks pandas. So what's happening here? How did this work? How is it finding the right thing? It's actually looking in your Python local variables. And it's looking for a variable named ducks_pandas. And it's checking the class name. Is this a class name I know how to read? Yeah, this is a pandas data frame class. I know how to read that. That's just C++ under the hood, just like DuckDB. So it's actually going to go understand how pandas is built in C++ and read the native C++ NumPy arrays directly. And it's not even going to have to copy it into the database. DuckDB is an in-process database. It's in the same memory space as Python. So it just looks at where your data frame is and reads it right where it sits without even copying it, and you can hit it with SQL. So it's on a zero copy for all simple data types, zero copy SQL operations on any data frame you've already got. So really, really powerful, great to mix and match with existing workflows that you have. And then when you want to get back into Pandas, say maybe your next step is to chart or plot something. Maybe your next step is to throw it into scikit-learn. Just .df at the end, you're back in Pandas. So we use Pandas read CSV instead of DuckDB in this case. When would we want to use that? Sometimes it's helpful because Pandas read CSV has seen some things. It has seen some serious CSVs, and there are a lot of them out there, and it can handle the craziest CSVs you've ever heard of. And it's got 20 parameters on there because it's seen some things. So that's a great reason. DuckDB is typically going to be faster. It's going to use all the cores in your machine instead of one, and it can handle larger than memory data. So it won't read it all into memory all at once. You can write it to a table instead of putting it all into memory. So DuckDB it's actually a pretty good replacement for Pandas read CSV if that's one of your key use cases for Pandas. But again, there's some gnarly CSVs out there. So that's Pandas. Pandas is everywhere. It's hugely valuable and very important. However, it's also been around since 2012. It is no longer the new kid on the block, and it's not the fastest data frame out there. So DuckDB also works perfectly with two other data frames, Polars and Apache Arrow. Polars is built on top of Apache Arrow. It uses their memory format with some slight adjustments, and DuckDB is fully interoperable with them. Apache Arrow, how many folks have heard of Apache Arrow? Sweet. Apache Arrow is the industry standard data transfer format. It's a standard across languages, which people got programmers to agree. Pretty amazing. Okay, we have to give massive credit to Apache Arrow folks. Voltron Data folks are great folks. So that's a big deal. Being able to be interoperable with these standards is very important. So for you to be able to do that with any arbitrary SQL query, to also be able to send and receive in the industry standard format, you're just going to import Polars and PyArrow in your PyArrow CSV reader. And we're going to do the same operation just in these two other ways, so you can kind of choose your favorite. So we'll get duck polars with reading the CSV from PL read CSV. And again, we're just going to do select star from ducks polars. And it's going to figure out what class it is, looking in your local variables, and say, oh, that's polars. I know how to do that too. Same result. Similarly, we've got PyArrow CSV, and it'll also read arrow. And you can also return it back. So .pl returns you to polars, and .arrow returns you to arrow. Mix and match. Yes? What are all the double quotes? Great question. So that is a multi-line string in Python. So that's a core Python language feature. So it would work just as well with just one, if you'd like. However, if your SQL statement had to have a double quote in there, suddenly you're having to escape it and all that baloney. If you always do the multi-line, not only can you format your SQL statement all nice, everyone has a different favorite format of SQL as well. We can't agree. But this is an easy way. You can also do it with 3 single quotes if you'd like. I just am in the habit of 3 double quotes for some reason. But that is, it's one of those Python features where unless you really need it, you don't need to worry about it, but it's handy. Thank you for the question. All right, questions about back and forth with data frames. This is the easy on-ramp. So you've learned SQL today. You know enough to do a lot. Now you can fit it anywhere. Wherever you're doing anything with the data frame, if you want the next line of your code to be SQL, it can. And if you want the line after that to be a data frame, you can. We got you covered. So let's do some examples. Let's take a look at it. So first exercise here, use Apache Arrow to read in a CSV file, and then use DuckDB to execute a SQL statement on it and find the maximum wing length in the whole data set. And then give that answer back as Apache Arrow as well. The next is to use the DuckDB Python client to return these results as a polars data frame. So you're going to be running this SQL statement, and then you want to go ahead and get it back as polars. And that multi-line string is going to come in handy. Don't want to have to go reformat that.
We are missing a download statement for birds.csv.
Really?
You can add that record.
Do we use the birds? I don't think so. Oh, we do. All right, I'm going to ask you guys to do a little bit of copy and paste for me. I did not re-download our birds.csv file. So if you go back to the previous tutorial at the very, very tippy top, our lovely wgets here that download the birds.csv file all the way at the top. Please go ahead and copy this and run it in this notebook that we're in. So just make sure to go ahead and grab that birds.csv. You might be okay because it might already be there from your previous notebook, but make sure to have it if you don't. I don't know where the others are. All right, would anyone like some additional time? Awesome, let's do it. Well, let's take a look at the examples that we just did. So we wanted to do some CSV reading with Apache Arrow, and then we wanted to hit it with some SQL and get an answer back. So how many lines of code is that? If you want to crunch it all together, it's only 2 lines of code. We're going to grab a CSV, turn it into an in-memory Apache Arrow table. They call it a table instead of a data frame, but it's essentially a data frame. And then you go ahead and do a select max wing length. And again, here you'll see I did not capitalize max. You know, it's much nicer if you capitalize it. It's all formatted nicely, but I cheated. And then you'll grab it from that arrow table that you just created. Now, Apache Arrow has a lot of different data types. They don't all have to be all in memory. So there are things called record batch readers, and they have a scanner API that allows you to point at like a directory of files and only read in the files that you need and do it all kind of streaming, where you don't have to read it all into memory, just like DuckDB. So if Apache Arrow can read the data types that you would like and DuckDB may not, there's actually ways to handle it where it'll handle larger than memory data as well. So Apache Arrow is really powerful. And then to get it back as Apache Arrow, we'll do .arrow. The next one here, we already had our SQL statement. We wanted to get it back as polars. So this is just kind of practicing how would we do that? Well, we'd use our multi-line string trick here with duckdb.sql. And that way we can use those single quotes in here for the birds.csv. Technically, those are optional as well. DuckDB will figure it out without those single quotes, but it's nice practice. And then at the end, you'll do .pl to get back into polars. All right, so now we get to talk about a library called IBIS. So what is IBIS? IBIS is a library created back in 2012 by Wes McKinney, who created pandas. And IBIS is using a DataFrame API, but it's executing on a SQL database backend. And it can work on 20 different databases. So you could write your code once and run it on as many different databases as you need. And their default engine is now DuckDB. So by default, when you get started with IBIS, it's going to use DuckDB as the execution engine under the hood. And it's going to go ahead and convert your data frame operations into SQL statements and then execute those SQL statements. It's powered by, as well today, a library called SQL Glot, like Polyglot, but for SQL, that does dialect conversion across all the many different flavors of SQL that are out there. And that's part of how it's able to work on so many databases. So SQL Glot is another cool tool to use. If you are trying to migrate databases, it'll get you pretty far. There's always edge cases, as we know, but it'll get you pretty far. So in this case, we are going to use IBIS to show how to mix and match data frame style computation with SQL all in the same statement. So you can really mix and match even within the same, functionally within the same query, which is pretty powerful. So we'll go ahead and pip install IBIS, and it comes with DuckDB, but we're going to specifically say it. And we're going to just set a couple of settings in IBIS. What we're going to do is we're going to import this underscore here, and we'll use this for building up expressions. So it's kind of a wild card that we'll use. And then we're going to set it into interactive mode. By default, IBIS is lazy, whereas Pandas is eager. Pandas is going to execute every single step directly, whereas with IBIS, you're kind of building up a query, building up an expression, building up a SQL statement, and executing it once you have that full statement built. And so it's a little bit of the best of both. You can build things up in steps, kind of like we did with the with clause, but even more granular. And then you get all the benefits of the database deciding how to optimally do it for you. Taking that where filter and doing it as early as possible. You can put the where clause, the where we'll see is the filter statement wherever you want in your IBIS query, and the database will do it as soon as it can legally do it. So you get the best of both. You write it in the natural way that's how you think about it, but the database will run it optimally. We are turning that off with interactive mode. It's going to execute eagerly like Pandas, and that's just because it's easier when you are in front of people with a Jupyter Notebook, not for production. So we're going to go ahead and connect to DuckDB, and it's just ibis.duckdb.connect, and we'll give it a database name. The jokes don't get better. What's quack-a-lagging? And then we're going to go ahead and read a CSV. And IBIS has a read CSV function, just like Pandas, and it's going to use the DuckDB read CSV under the hood. And we'll go ahead and just put the variable here, so Jupyter Notebook will display it for us, and they have a really nice string representation of their tables. You'll notice in like Apache Arrow, it's like a miserable string representation. Love it, but dang it, I'm never going to look at that. I'm always going to turn it into something else. IBIS is very nice. It's color-coded, gives me my data types. Nice way to work with it. And you got the dot, dot, dots. It's got a lot more rows than just what we see here. So what we get back from that is we get an IBIS object. And we can start to build a lot of things on top of that IBIS object. However, it's like a SQL query. It's not saved to your database unless you run like a create table statement on top of it. So we took our CSVs, we put it into our database with create table, then all those other SQL statements that we ran were ephemeral. We just get the results back and use them. It's not saved. So if we want to save something, we're going to go ahead and we're going to create a table. We're going to give it a name, and we're going to pass in this object here, this ducks underscore IBIS. We'll convert it to PyArrow because that's the universal format, and it's built by the same team that built Arrow. and continue to build arrow. And we're going to go do an overwrite is true. So that's basically your create or replace. So this is functionally a create or replace, but it's in DataFrame syntax. And we will get the answer back, interestingly as well. IBIS will also give you the table back as another object to keep working with, which is kind of nice. In SQL, you just get back a row count. You just inserted, 100,000 rows. It's like, okay, great. Now I need to go pull it. Well, happens automatically with IBIS. So we have our table. We've read a CSV. We've stated it as a persistent table. Now that we have it set up, how do we go ahead and query it? How do we write our queries? And hopefully it'll feel fairly similar. As part of the benefit of learning SQL this morning, using DataFrames, there's a lot of commonality. In this case, we're going to use the filter function instead of the where clause, but it's very, very similar. We're going to take our persistent ducks, because it's persistent because they are saved to a table. Once again, jokes don't get better. And we're going to do a Boolean expression here, where extinct is 0. We want all the ones that are still with us. You'll notice, though, we're back in Python. We've got to do the double equals. All right, we also have the ability to select columns with a very well-named, in my opinion, select function. So we can chain these together. So another trick, if you don't want to chain them together all in the same line, you can wrap them in parentheses. This is just kind of a Python trick. And that way you can have your persistent ducks up here, and each row can be a totally separate function operation. Just keeps it really nice and clean. If I wanted to assign it to a variable, I could say, var equal to my parentheses. In this case, I just want to display it in my Jupyter notebook, so I just have the parentheses there. And so I get back just 3 columns of ducks that are alive. So now we're going to also do our group by clause. And in this case, we want to group by author, so the people that found the duck, and we want to see how many did they find and what year did they start duck hunting, for species anyway. So we will filter to where things, where ducks aren't extinct. We'll pick the columns that we want, and we will group by our author. What's nice about this is we can put this group by anywhere. I could have put it first in the list. I could put it last in the list. You don't have to worry about the order. It's going to do it optimally on your behalf. So we're going to group it, and then we're going to go ahead and aggregate. And this is how they also would handle kind of what you would typically do in a select clause. Instead of having it be in select, you have it separated out in this aggregate clause in IBIS. But it's functionally the same as the select clause in SQL that had anything wrapped in an aggregate function, like your averages, your mins, your maxes. And then we will order. And we will order by ibis.descending. So this is using instead of a keyword, we're kind of using a function inside of the core library to do descending. And then we will order it by our count, descending. And you can see we're passing in lists here. So that way you can do this with multiple things, just like you can with SQL. And what we get back is what we expect. Only 3 columns. By author, how many ducks did they find and when did they get started? Well, it turns out you had to get started pretty early, 1758, if you want to find them all. And we'll have a chance to practice this very shortly. The last thing I'll mention before we do, well, I think we got a couple more examples. We can also do ToSQL, and you can see what IBIS is doing under the hood for you. In this case, it's a little more nested than what we've dealt with, so it's got some subqueries, but fundamentally it's very similar. When I look at subqueries, I always start with the innermost, just like with Python, and then work our way out, order of operations. So the innermost is here. I'm going to grab the 3 columns I put in my select list, and I'm getting it from my what's quack-a-lack database. And this is a fully qualified table name. We always just had, one database, but in this case, we're talking about database name dot schema name. It's basically just a grouping dot table. So we've got what's quack-a-lackin dot main dot persistent ducks. And we've given that an alias. We've renamed that table here, so we don't have to type that whole dang thing everywhere. So we just call that T0. Not as creative. I'd rather name it something I could actually understand, but it's T0, and so we're using T0 to refer to it. And we are filtering with a where clause. Now, if we move one layer out of our subquery, that's going to look here. So the next layer out is I'm doing my aggregation. Sorry, that's right out here. So we're grouping by 1. What's happening there? Well, SQL allows you to refer to columns by position if you don't want to refer to them by name. So we're saying group by the first column that shows up, group by 1. This is great if you have 20 columns, you want to group by all 20. But it can get pretty messy if you say delete one in the middle. It's a real big pain. So I really wouldn't recommend this when you're writing SQL yourself. But if you're seeing SQL written by someone else or by a machine, you might see this. So in this case, this 1 is referring to author. It's grouping by author. And then for every author, every discoverer of a duck, we do our aggregates, count and min. And finally, we wrap this again with another subquery, and we do that just to get our ordering here. So we order it by the people that found the most. So I'm going to go ahead and skip to one of our exercises, and then we'll go back to the next section. So skip with me to exercise 3.03. And in this case, we just looked at that SQL that IBIS wrote, and it is not the most concise. You can actually do more in one statement than splitting it up like this. So can you rewrite the SQL that IBIS generated into a single statement? And so this is that same SQL statement here. It's just nicely color-coded and just for reference. But can you rewrite that into one statement? Do it all in one shot. And we'll give you a couple minutes. We'll do another minute or two. Anyone have any questions? Feel free to raise your hand. Who would like a little bit more time? All right, well, let's take a look. We got some other fun stuff to look at. We've got 10 minutes or so till our final break. So this is also kind of a fun idea of you won't always be the one writing the SQL. Sometimes you'll be reading it. And code is read more often than is written. So really, you're going to be decoding what the heck is this SQL doing if your role ends up anything like mine. It's a lot of what the heck is happening here? And then you got to kind of parse it out. So let's go ahead and go step by step with this query and see how we can simplify it a little bit. So the first thing is starting at the innermost layer. All we're adding here is a where clause. Well, we've already had some examples where we do a where clause and a group by at the same time. So we don't necessarily need to just have the where clause separately. We can do the group by at the same time. So we will compress that together. And then this other nesting layer here, all this nesting layer is doing is ordering. But we've seen another example where we order by in the same clause as well. So IBIS is doing this nesting because it's having to build this programmatically. And for them, lines of SQL are very inexpensive because it's not really reading it, it's just generating it. It's a machine. But for us, sometimes it being concise, being all in one step, is going to make it easier for us to interpret, easier to fit on, on a monitor. So if we were to rewrite this, we could do it all in one statement. And I always start with the from clause. So we're going from our persistent table, persistent ducks. And then we want to grab our author, and we want to aggregate things up by author. So we need our author in our select clause, and we need our author in our group by clause. So now we're looking for every author, everyone who's found a duck. Let's get those metrics. We'll get our count, and we'll get our first year that they found one. So now that we have that, we've got our where, we're filtering it down, we're grouping it, and then we're ordering it all in the same clause. So we can do it all at once. So under the hood, kind of what order is SQL really doing this in? Well, step one is going to be finding the table. And while it's reading that table, it's going to be applying the where clause. So it will not even read off of disk anything it doesn't need based on that where clause. It's going to leave it there in a lot of cases. And then after that, it's going to go ahead and do the aggregation. It's going to do the grouping and the aggregate calcs kind of in the same step. It's going to build up a big hash table and find all the unique groups. And within each hash, it's going to go ahead and keep track of those metrics and say, okay, for every author I've ever seen, what is that minimum year I've ever seen? And then the final step is it's going to do the ordering. It's going to say, okay, now that I've aggregated things up, I found all my unique authors, I know how prolific they are, let's sort them. And the sort is the final step. But we can write it all in one. And this isn't really telling SQL how to do this. We didn't have to tell it really what to do first. We just said, hey, this is what I want. Show me all the ducks, the people that have found ducks, where the ducks aren't extinct, and show me the ones who found the most. And it's going to do that work for us. Any questions there? All right, well, let's do some more Python. Let's look at IBIS a little bit more. So our next step here is to really mix and match. So IBIS is using SQL under the hood, so it allows a nice escape valve to use SQL whenever you need to. You might ask, well, why would I do that? I've got IBIS, it's going to build it for me. And in many cases, that's absolutely true. However, each database has their own secret sauce. We've seen some with DuckDB. Every other database has it. And sometimes that is really how you get the maximum performance out of your database. Maybe the import is a little bit different, what have you. So there are reasons to drop down into SQL. It's also really great if maybe you're working with someone on your team and they're a SQL fan and they send you a SQL query. And then you're like, man, I just want to run that SQL query and do something else. You can run that SQL query first and then do the rest in IBIS. So you can mix and match. So there's a few tips and tricks to be able to do this. So when you're referring to SQL first, you can just say IBIS object.SQL. And then you can refer back to that IBIS object in your from clause, persistent ducks, just like with DuckDB. It's just going to go ahead and understand that object in memory and go read it. So you can, if you're starting with SQL, you can do that. We'll see if it's kind of later on in your IBIS expression, you've got one little extra hoop to jump through. But here we can just do .SQL and run a SQL statement. And then I can do whatever other IBIS operations I need to do. However, we are no longer referring to persistent ducks anymore in that query. What we want to do is refer to the ongoing operation, kind of the ongoing expression that we're working with. That's why we're using this underscore. And we imported that with from IBIS import underscore. And this is just an expression builder object. And what that allows us to do is it contains all of the columns in the current expression. So we've already selected name, we've already selected year, and it just already has those in the object. And so then we can apply aggregate functions on top of it with .count and .min and do that. But we can't refer to persistent ducks anymore because we've modified it. And we've modified it in what's kind of a black box way to IBIS. We said, just use this arbitrary SQL string. Don't worry about it. Don't worry about it. Don't worry about what's under the hood. Just do it. And so we need to go ahead and tell IBIS to stop looking at persistent ducks and look at the underscore. And then we can do our order by just as before. And so this is going to return the exact same answer. But we did part of it in a language, in our Python language, part of it in SQL. Now let's mix and match in the other direction. Let's do the final statement of SQL. I am more comfortable with the order by clause of SQL. I don't really remember ibis.descending or ibis.ascending. I just haven't used ibis enough. But I know SQL. So I want to do my order by in SQL and do all the rest in ibis. So I've got my filter, my select, my group by, my aggregate, and I need this extra step here, an alias. This is so that I have something to refer to in my from clause of SQL. I need to give all the rest of what I've done so far in ibis a name. Say everything you've got up to this point, this is my name for it, ibis duck. That way I can then do select star from ibis duck and have my order by clause after that. So that's the only trick. If you want to use SQL first, no trick needed, just .SQL. If you want to use it later after you've done some calculations in ibis, you have to name that set of calculations. And then you're back up and running, back to SQL. And we will see the exact same answer here. So, we've talked about a lot. We've covered a lot. It is a crash course for sure. Question? That's a good question. I would have to check. You would probably want to do the underscores, and I'm sure you could alias it as well if you wanted, so that's probably an option too. But if you try it, maybe you could earn a t-shirt. All right, thank you. I should know that, and I will know it later today. All right, so we've made it this far. What have we covered just in section 3 alone? You can now read and write pandas, polars, or Apache Arrow, back and forth with DuckDB. You can use IBIS to run DataFrame queries with DuckDB as the engine. So you can use a total DataFrame syntax, but get the power of DuckDB's engine. So you get all your cores, full multi-core, and you can handle larger than memory data sets. So you can do analysis on a terabyte on your laptop instead of just 16 gigs. So 100x the scale. And you can see what's happening under the hood with IBIS. What is the SQL that is running on your behalf? And we can mix and match. Whenever SQL is the right tool for the job, we can do it. Whenever it's Python, we can use Python. So a fair bit in 45 minutes. So we just have one other example here, one other exercise, and then we'll go ahead and take our last break. So convert this SQL query below into an IBIS expression. So this is, the quiz at the end, right? With this, I'm giving you an option as well to ignore the column naming. We did not talk about that with IBIS, but you can rename columns as a part of it. The solution has that if you're interested. But just focus on just doing the actual operations, the grouping and the aggregating, and see if you can do it in IBIS. I've got a couple hints below as well. Feel free to take a look at that. I've got the link to the docs, and we have our solution as well. So this is a bonus. You're in a SQL class, and you're doing DataFrames too, so how about it? We'll do a couple minutes, and let's just go to our break. So come back at 11, and we will go over this result and move on to the next fun stuff. Thanks, everybody.
doing? don't have really great interoperability with R yet. I mean, there is an R library for DuckDB, but there are some issues with it, but it's on our to-do list to work on that. But typically, what I would recommend if you use R is use DuckDB to prepare your data. So to like read the data, make a sub-selection or a filter, save that to a file, and then read that for a file. And then do your work. Yeah, you're welcome. Good question. All right, we got a few more minutes of break, so if you still need to use the restroom, get some coffee or tea, take a look at the duck tub, see if you can use your sixth sense to count the ducks in your mind's eye. Now's your chance. We'll start in about 2-3 minutes with section 4. Yeah, of course.
So we had a great question from a couple of folks, and the question was, those two queries, the one that IBIS provided us and the one that we rewrote to be simpler, which one would be faster? And the answer is they both run at the same speed. Because what the database is going to do is it's going to choose how to optimally do this, and that optimization step is actually, in most databases, intelligent enough to collapse things down. And so really, we were just doing that practice for our human interpretability, but the database is going to run just as fast, even with those nesting steps that we saw with IBIS. So pretty neat.
That's a mug question, isn't it? What do you think?
Well, that was a very good question, but two people asked it, so we
Oh.
can't split the last mug in half.
We can't. All right, before we dive into our last section, again, if you have a question, just raise your hand because we can't see the Post-it notes very well. Sorry about that. Just as a reminder, the feedback form is at motherduck.com/SciPy. Fill it out before the top of the hour, so we've got until noon. Fill it out with your best guess for the duck tub to be able to win the prize. We're going to try and count all the ducks before noon so we can announce the winner at the end of the tutorial. So this is your chance. Just, it would also be nice if you could fill out the rest of the form. Give us some feedback, of course. That's a catch. All right, let's get started with chapter 4. Collaborating with data in the cloud. So to get there, just click on the Open in Colab at the top of any of the notebooks, and it will show you the overview of all the different notebooks. All right. So who has signed up for MotherDuck? It was part of the setup instructions. Okay, see some hands. Great, okay. Well, if you haven't signed up yet, we will go over those steps real quick as well. It shouldn't take too long if you have a Google account. It's just a one-click kind of thing. All right. For this tutorial, we're going to need, okay, now run. We're going to need DuckDB. Oh, I've got too many sessions. This might be, other people might have this problem too. You can just close down some of your earlier sessions. I think Colab free, the free version only lets you run 3 sessions at a time. All right, let's try this again. Connect. All right. So we need DuckDB, we need Magic DuckDB like in all the other tutorials, and we also are going to use Dash because we're going to be sharing data in the cloud, so we thought it would be nice to also show how you can visualize your data and share it in dashboards and stuff like that. All right. Then we're just going to create a quick helper variable. This is just for the tutorial, not really related to SQL or anything, just to see if we're running in Google Colab, because some of the MotherDuck authentication steps are going to be a little bit different depending on whether you're using Colab or a local Jupyter notebook. All right, So if you haven't already signed up for MotherDuck, please do so right now. There's a link right here that lets you sign up. It's going to redirect you to this app.motherduck.com/sign up. So I'm just going to open that in an incognito window because I'm already signed up. And that's it. And then it lets you choose an email address and password, or lets you continue with Google and sign in with your Google account. So let's see how I can get back. There we go. So it's take a couple minutes for everybody to do that. This is by far the easiest way to share your data with someone, aside from emailing, but that's actually a lot of clicks if you think about it. While everybody's getting it set up, if you've already signed up for MotherDuck, you can actually go to app.motherduck.com. It's going to get you to the app. It's going to have some sample queries in here that you can run and try. It's not going to be part of the tutorial, so feel free to do that in your own time. But the thing I wanted to point out, let me see if I can increase the font size over here because it's a little small. People in the back. MotherDuck is a cloud data warehouse based on DuckDB. So it runs seamlessly with DuckDB, which I'm going to show you in this tutorial. After you've signed up and created an account, you're going to have two default databases. You're going to have MyDB, and you're going to have sample data. Sample data, as you can see when you hover, it's a read-only database. We're going to use that to just do some queries. And then MyDB is your default read-write database. So that's the database we're going to be using to write your data. It's very similar to a DuckDB file. So if you just store a database in a file like we did in one of the earlier tutorials, I think it was called What's Quack-a-lack-in.DuckDB, instead of storing on your machine, this is going to be stored in the cloud, and you're going to be able to do cool stuff like sharing and other kinds of stuff. All right. Everybody signed up for, if you still need a minute to sign up, or, yep, raise your hand and get some help. All right, great. So what are we going to do? We're going to import DuckDB and then DuckDB.connect. It's simple as that. It's the same as how you would connect to any other DuckDB database, except now we're going to use the MD : prefix. And let's connect to the sample data. All right. So this is a bit of a gotcha because this is going to fail. All right. Why? Let's look at the error. It actually asks for a token. It says, I cannot connect because I don't have a token. So how are we going to do that? So there's this handy dandy link here that you can click that's going to get you straight to a dialog that lets you copy your token. So we're going to do that. Click on copy token. And you go back here to your Jupyter Notebook in Colab, or your other favorite Jupyter Notebook in VS Code or anything else you're using. I'm just going to show you how to do this in Colab. There are some lines below that I've commented out that you can use if you're not in Colab. So if you're not in Colab, just skip and go straight there. So let's add it to the secret. So click on this key icon here. I'm just going to delete the old ones. So click on Add New Secret. You can name it Token. Then paste the value you just got from the browser window that just opened and paste it in here. And then toggle the notebook access button. And then you can hide it if you want. And that's it. Now we're going to run this cell to add it to your environment variable. So your MotherDuck token is now going to be stored in environment variable. If you're using local Jupyter notebooks, you can export it. If you're on Unix, you can export it. Or if you're on Windows, you can set it in environment variables. Just make sure it's called MotherDuck token and it has that token that we just copied. Again, these are the lines. If you're if you're in Spider or whatnot, it's going to prompt you for the token. So that's our exercise here. So go ahead, create a connection to MotherDuck and show all your tables in the sample data database. So basically, you're going to run the lines that I just tried to run that failed. I'm going to just copy this over. For the beginning of the exercise, just going to show you how to get started. And then use that connection object that Alex just explained how to use to run the show tables command. And if you need more documentation, you can read it here. So take a couple minutes to do that. All right, just put up your yellow post-it note if you got everything to run, just so I have an idea how many people still need a minute. All right, I hope everybody got the connection working. So we found out that if you do show tables, it actually gives you an empty result, which confusingly it should be show all tables. So, bit of a gotcha, sorry about that, but show all tables is gonna work. We will update that in the tutorial, so thank you for that question. I think it was, I don't know, Jared? I didn't see you. Thank you so much. All right, so let's take a look here. So I'm seeing I've got a couple databases, MyDB and sample data, like I was expecting. And then there's a few different schemas. So I think Alex explained to you what the concept of a schema is. So it's kind of a grouping of tables. So I've got my main schema, which is my default schema. As you can see, I already did the tutorial. So these are going to show up for you later after you've actually run the rest of the tutorial. Then sample data has Hacker News, some data from Hacker News, some data from Kaggle, some New York City rideshare service requests we're going to use for this tutorial, and then ambient air quality for the World Health Organization. Oh, can I ask somebody, Alex, would you mind closing the door? Thank you so much. All right. All right, you're now all ready to go and query your cloud data warehouse. Sounds very fancy, right? Got a cloud data warehouse. Okay, so apparently New York City has this 311 service requests. My colleague Elena lives there, so I don't, but I bet she knows all about it. Which, with requests to the city's complaint service from 2010 to the present. So to query data, kind of like in the previous section, you want to fully specify the table name. Because we want to make sure that we pick the right schema. You don't necessarily have to do this. DuckDB is smart enough to figure it out if you have a unique table, but if there are duplicate names from different schemas, you're going to need to fully specify. So here's an example to run this to get the service requests between March 27th and March 31st of 2022. So I'm selecting my column names here, created date, agency name, etc., complaint type, whatnot, from that table here. Also note that instead of just using the DQL magic command, I'm now passing the connection that I created earlier, right? So as I scroll back up to the previous exercise, we created a new DuckDB connection to the sample data database in MotherDuck. And now we're passing that to the DuckDB magic here as the connection to use. So if I run this without specifying this, I'm going to get an error because it can't find the correct database. And then here I've got my where, my filter. You guys are now experts on this. And yeah, as you can see, there was some graffiti on 101 and some illegal dumping and whatever people in New York City thought was okay to do, but other New Yorkers were unhappy about. All right. Now we're going to look at another data set in our sample data database called ambient air quality. So this exercise is run a describe on this, or you can also use summarize, which should Alex explain in one of the previous sections. Inspect the column name, see what's in there, and then write a query that gets the average concentrations of PM1 and PM2.5 particles for the United States of America, or your home country if you're not in the US, for the last 10 years, and group and order it by year. So I want to see the average concentrations of PM1.0 and PM2.5 particles for the US or your home country for the last 10 years, grouped and ordered by year. So we're going to be using an aggregation, grouping, ordering, and we're doing a select as well. So make sure not to select all of the columns, but get some relevant ones. I'm going to leave it up to you to do that. And I'm going to give you a few minutes to do that. And again, if you have a question, please put up your hand. If you're done, put your yellow post-it note up. If your post-it note is still up from the last exercise, please take it down so we know how much time everybody needs. Thank you so much. So you might think that this duck tub is just a silly joke. It is a silly joke, but it's also pretty representative of how MotherDuck works. So the way MotherDuck works is you have a DuckDB instance on your laptop. MotherDuck, which is represented by our friend the Trojan horse duck, has a DuckDB in the cloud, and they talk to each other. The cool thing about this is that you can do something called dual execution. So if you run a query on a local DuckDB like we did in 90% of this tutorial so far, everything's running in memory, in process, on your local machine, which is very fast and awesome, especially if you have a fast laptop. But if you have data that's sitting in the cloud, maybe like a few gigabytes or something like that, and you only need like 100 rows, right? It's actually really inefficient to download that whole file, load it into memory, and then do your filter on the client side, on your local machine. So that's why we've got these two duckies. I've got a friendly duckling, we call him, in the cloud, that's going to be doing the filtering for you, then sends over the minimum possible amount of data to the duckling or DuckDB instance on your laptop, so you have a faster experience getting data from the cloud. So we're not going to go into that too much in detail during the tutorial, but just thought it'd be fun to show. If you're interested in more detail how that works, you can come to my talk on Friday afternoon, just after lunch, around 1:15 or something like that. All right. Can I see some yellow Post-its if you're ready? If you're not, I've got a hand up over there. All right, and I'll give you guys in just a minute before we go into the answers. All right. Unfortunately, I made a mistake with the answers, so we're going to need to... Oh, you got it, Elena. Thank you.
I came to ask that exact.
Yeah, okay. I'm going to just show the answer on the screen. Sorry about that. What's a snafu here? I'm going to just copy this into Slack. So you got it? Okay. All right, so this is the answer, or an answer. Obviously, there's no one answer. Everybody, you can write the SQL that you want to write. All right, so what I did here, I selected the year, and I grouped by year and country name. Whoopsie. I also did something here we didn't explain yet here, but I cast this to a string just because otherwise it will show decimal point, and years are typically not used like thousands, so just put it as a string here. Then we are going to aggregate on the particle size here. Oh, this is not good. And then where year is above 2014, so 10 years ago, and the country name is United States. And we're going to also order by year and country name. There we go. So I'm just going to leave this up a bit since the answer keys are not working in this notebook. But yep, if you got close, just make a few edits if you got it. So you can see pollution went a little bit down and then it went back up. All right. All right, now, who has data that they're working on that's mainly on their laptop? Like if you work with data, is it all or mainly on your laptop? Someone over here? Okay. Who's got data that's somewhere else? It's on a server, on a cluster, on someone else's computer. Yeah, that's most people here. DuckDB is great at that. If you're familiar with Hugging Face, it's one of the major websites. If you want to get into machine learning, they have a whole datasets library. So there's a link here if you want to check it out. Hugging Face recently released an extension for DuckDB that lets you, similar to what we just showed, what you can do with MotherDuck, is that you can just do MD colon and the database name. You do something very similar with Hugging Face. So you can do HF colon / datasets, then the name of the user who created that dataset, and then the name of the dataset, and then here is some path in that dataset to a Parquet file, CSV file, DuckDB file, etc. Hugging Face actually has a lot of native integrations with DuckDB, so maybe a show of hands, anybody here use Hugging Face for their day-to-day jobs? Yeah? Well, you're going to have a great time with DuckDB because it's going to be very, very compatible. So, okay, let's run this. Again, we're going to run it from MotherDuck, so we're going to pass the connection object here to the DuckDB magic command. And there we go. This is a data set downloaded from Hugging Face. Like I showed you those two duckies. There's one ducky on your laptop and one ducky in the cloud. The ducky in the cloud is going to talk to Hugging Face and say, can I have your data? Downloads it. This is going to be very fast. And then if I do any filtering or anything like that, that's all going to happen on the cloud, and I'm going to get the data back. All right. So before we create a new table with this data, we have to first swap to different databases. So we connected to the sample database. So let's use the default database. For that, you can use this use statement, use MyDB. Success. All right. Next exercise, create a new table called animals in your MotherDuck database based on this data set from Hugging Face. So this should be maybe a couple minutes. And again, I'm going to go and download the answers into this notebook. Oh, thank you. All right, that's downloaded. So a couple minutes before we walk through the answer. No need to use your sticky notes for this. I think it'll be relatively easy, fast. Meanwhile, I'm just going to go and open that link. So it's huggingface.co/datasets. So again, here you have access to any of these data sets. Let's see if there's anything with ducks. Oh yeah, ducks, rubber ducks, crossway ducks. What's that? So yeah, what I can do is copy this. And use it in a similar way as here. I guess I need to full path to a file, but that's a later exercise. All right, so let's look at the solution. Create or replace table animals as select star from read parquet file path. All right, very cool. So if you now go back to your MotherDuck account, if you go to app.motherduck.com, in your MyDB file, you should now see this table animals that's just been created. As mentioned before, I used create or replace table just because I ran this tutorial earlier, so I already have the table, so it would throw an error if I try to create it again. But this always guarantees that the table will be created if it already exists. If you don't want to override it, you can use create table if not exists, which is another useful syntax to know. All right, next exercise. DuckDB releases are each named after a duck. As you can tell, people at DuckDB, working with DuckDB, really like ducks. So let's load this data into a new table called DuckDB ducks. Again, you can use read CSV here. So instead of using read parquet, we use read CSV. And then just use this URL. So take a look at that. And once you're done with exercise 3 and 4, just put up your yellow Post-it note, please.
So if you've already finished that and you have a spare moment, we did not include the answer key inside of this, so we're going to put it in the community Slack. So if you go to the SciPy community Slack, there's a channel already for this tutorial, all the SQL a Pythonista needs to know, and hop in there and we will go ahead and be pasting those answers in there, probably as we wrap up the session.
See those yellow Post-it notes? Let's see a handful of them. I think everybody... Yeah? Need more time? Anybody? Okay. All right. So let's look at the answer, which Alex will be posting on the Slack channel. Here, create or replace table, DuckDB ducks as select star from read CSV. So here we're going to use read CSV instead of read parquet. There we go. 41 rows. So if you now go to your MotherDuck app, you should be able to see DuckDB ducks in here. So it's got the release date, version number, code name, species, etc. All right, let's keep going. Oh, and I'm gonna steal a bit of that SQL hype person role. Hype. You've just done your first query in the cloud. Yes, cloud ducks. Ducks can fly. But now your data can fly too. So let's do that. Sharing is caring. Now we have two tables. We can join them together and share them with our colleagues. So let's first inspect the tables, see what we have. So we already saw that in the MotherDuck app, you can already see what are the column names and stuff, but yeah, we can do that again in our notebook. So now let's get the endangered species status of all of the DuckDB ducks by joining these two. So the first table, animals here, it has a scientific name column, and then it has a category column. So the category column is actually, let's see, I think it's on Wikipedia. It's the endangered species status. So it's like a 2-character abbreviation that tells you how endangered the species is. So get these 2 columns from the animals table and join them into the DuckDB ducks table. So then we'll have, you know, release date, version number, DuckDB species. So DuckDB species primary is the scientific name. So you're going to want to join on DuckDB species primary and again scientific name. And then we'll have 2 more columns here, or 1 more column called category. So that's the exercise. Take a look at that one. Oh, and create a new table out of that. So create a new table called DuckDB species. All right, moving on. Let's take a look at the solution. Oh. So we're going to select the release date, version number, duck species secondary, scientific name, and category from DuckDB ducks. Join it against animals to get that endangered species category on, and then the 2 columns that overlap. So let's do that. And then you'll see, all right, the latest version. I guess we can order it by time as well if we want to be fancy. Yeah, go ahead.
We had another great question, and it's mostly just kind of a way to think about what is that read parquet doing. So when we have that read parquet function, you can think of it's called a table function. So it's basically impersonating a table. So anywhere that you would have a table or like a subquery that we've been doing, read parquet is impersonating that. So that's why you need to still say like select star from read parquet. Whereas with something like pandas, you'd be used to saying like, you know, pd.readParquet directly. But with SQL, it's got to be in your from clause because it's really pretending to be a table. There you go.
Great question. All right, that was it. We've done the hard work. Now to the fun stuff. Let's share our data. All right. So how are we going to do that? I'm going to add something to the magic command here, -odf. What that does is it saves the output of my query into a pandas data frame. So let's create a share. So this is very mother duck specific syntax. Create share, let's call it the duck share from MyDB access unrestricted. So let's unpack this. So I'm creating a share on mother duck. So I'm creating one of those duckies in the cloud that now is going to be flying everywhere else. I'm teaching it how to fly from the database where we created all our data. So that's where we put the Hugging Face data, or the DuckDB version data, and our joined table. Access unrestricted, that means anybody you share the URL with is going to be able to mount that or attach that database into their cloud data warehouse. Obviously, this also means I can restrict access. Won't be going into that too much right now, but you can create an organization, which I think you should have gotten prompted to do when you signed up. If you add people to that organization, you can also create shares that are only within your organization. So let's do that. And there we go. There's the share URL, and I can just conveniently print that to the command line. There we go. So now we can attach that. Somebody else can attach it if you create this share using the attach command. So the next exercise, look to your left, look to your right, or look behind you. There's nobody on your left or right. And tell them, I'm going to share data with you. So pick a data set, go to huggingface.co/dataset, pick a fun data set. Doesn't have to be duck related, can be your other favorite animal, favorite topic. Then go through the tools we just taught you. So go and create a table in your MotherDuck database with that data set using read Parquet, read CSV, whatnot. Then create a share and share it with your neighbor. And then once we've done that, we're going to go through and how to attach it. So to share it with your neighbor, you can find them on Slack or copy it in the group Slack, the tutorial Slack, and you can then copy it. So I'll give you 5 minutes or so. All right, Alex is going to be my neighbor, so he's going to create a share with me that I can attach. Oh, and don't tell your neighbor what's in the data set. It's like the surprise. They have to go and figure that out. All right, just some tips on how to navigate Hugging Face. So I found this data set called Tiny Stories, which is a data set that contains some fairy tales. Once upon a time, da 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 da. So how do I find the Hugging Face URL for that? So I go into, so I've got the dataset card here, which is a little overview, like with the license and everything. So I go into the Files and Versions tab over here, and click around. So there's, every dataset's going to be different, so it'll be different files. So I click on Data. So here you see there's a few Parquet files here. So click on that. Then you see there's the full path here. I'm going to go copy that. Right. Now I go back into, so let me just remove this. All right. So I'm going to start by typing hf://datasets/ and then I need the name of the user / the name of the dataset. So I can copy that here, go back in here. All right. And then /. And now I go back and copy that path over here and type it in there. So now you see HF datasets, name of the user, name of the dataset, / and then the path. So that's data/train .parquet. And I'm going to wrap that in a read parquet, select star from that, and now it's downloading the data and querying it for me. It's going to show you a progress bar as well. So here you go. This is quite a bit of data, 500,000 rows. So let's try and filter this down a little bit. I'm just going to do limit 10. So I'm just going to get the first 10. As you can see, this is super fast because all of the downloading is happening on the server, so on MotherDuck's side. So it's not actually downloading all of the data to my laptop. So it's kind of convenient. All right, did that answer your question? Okay. It's got a really good question. How do I find data sets that are actually loadable by MotherDuck or by DuckDB? So one thing we can try is here, there's a format filter here. So if you click on Parquet or CSV here, that should give you, oh, this is sorry. You do Parquet, this should give you data sets that have a Parquet file in it. So there might also be other formats there like Pickle or JSON, which we're not covering right now. So try that and see if that helps. All right, meanwhile, I'm going to show you how to attach a share. So for example, here I've got a share that already preloaded in the example. I'm going to take a share that Alex just sent me as well. But let's take this one first. So I'm going to attach it. All right, success. And again, I have to use the, sorry about that, the use statement. And then here we go, show tables. So it has some similar data that's in our sample data set. So some complaints for New York City, and then earthquakes, flights, 5 million row data set called Gaia, and then Seattle weather. So let's check out Seattle weather. All right. Looks like it got some dates precipitated. Oh, it's very similar to the other data set we looked at, but here it has also a little bit of qualitative data about whether it was a drizzle or rain or fog. You know, I've got all those words for various states of water in the vapor in the air in Seattle. All right, let's take a look at what Alex sent me. All right, Alex, did you send it to me on Slack? Oh, I've got Dan here. Data set for sale, cheap. I'll try that one. It's cheap. All right, big money. Let's try this. All right, I'm going to connect to MotherDuck again, and then I will do attach. And attach uses single quotes. So let's try that. Above exception, share alias cannot be the same. Oh, okay. Let's try that. All right. So many of you might have gotten the same error, so just rename it using as. So let's see what's in here. I have no idea what's in here. We're going to find out. I hope it's related to Markdown. That'd be fun. All right. What's in here? All right, I've got my sample data. Mosaic examples is in there. Earthquakes. Yeah. This looks like your database, right? Anything? Yeah, awesome. Cool. All right, so next exercise. Try that. Try attaching Dan's database. Try attaching your own, or I guess your own's not going to work because you already have it in your database. Try attaching your neighbors. Try sharing the one you created. And inspect the tables. Okay, hype man, alert.
It's very quiet if you're supposed to be talking to your neighbor. Resident extrovert here saying hello. Everyone has a ridiculous data set, so just see just how ridiculous your neighbor's is for fun.
Where did you send me yours?
Slack. It's very boring. It's databases. So
This one?
I put it in the chat with me, and
Maybe it's the different one.
it's in the SciPy channel.
This one?
Go all the way down in the DMs
Oh, this one?
of SciPy.
No. Okay, it's not on here.
Okay, sorry. I can send it in just.
Yeah, no, just MotherDuck community. Can you send in MotherDuck community? Thank you. All right, thank you. All right, I'm just going to attach the share that Alex created from Hugging Face.
The good news, it can't be any more boring than my data set.
Just trying to find what happened to my... Here we go. All right. If you don't do access unrestricted, you would get an error like the one I just got. It says, error executing attach. No database or share, because it can't find it. But Alex is going to fix that right now. Thank you. All right, there we go. Sharing is indeed caring. All right, so now let's take a look at that. I'm going to use sharing is caring. And then show all tables. See what we got here. Sharing is caring. Sorry?
It's literally a database of databases, guys. It doesn't get any better.
It's a data. I heard you like databases. Yeah, that's the one.
Who's got the best data set? Whose neighbor has the best data set?
Yeah. All right. DuckDB ducks. All right. Who's over there in the back? Pink shirt.
Who else had a good one? Or did someone just want actual help? And we were calling them.
I think it's time for the sound class. No more help here.
All right. I think we're nearing the end. But yeah, that's it. I think we've got one mug left. So I think that's going to go to Dan for sharing his cheap database.
I will, sure.
What's your medium, large? Medium? Okay. Great. All right, that's it. We can now detach the share if we need to. You can, or detach the attached database. So if you got a database from your friend, you can detach it again. If you gave a database to your friend and you're like, nah, I actually don't want to share the data anymore, you can run drop share. That will get rid of your share. Obviously, nobody can attach it anymore after that. And then that's it. We've got one last cell here you can run. This is if you want to visualize your data. I've just made a quick example here. Or, Elena actually created this using Dash. It loads DuckDB. It connects to your mother duck data in sample data. And then it selects the countries from ambient air quality table and lets you select a country and see the average 2.5 PM particles over a year. So this is kind of just a neat way to interact with your data. You can use DuckDB, it's all compatible, and you can use the entire United States Python ecosystem here and interact with Mother Duck and DuckDB. All right. So thank you so much, everybody. We are at time, but if you'd like to stick around maybe for like 10 more minutes, we're going to go and hand out the prize or for our duck-shaped tub estimation contest. So if you have not yet submitted the feedback form, please do so right now. We're going to start counting right now. motherduck.com/SciPy. We'll be back in 10 minutes. And then we can all have lunch. Thank you all so much for joining this tutorial. We had a blast. And happy querying, everybody. Okay.
Welcome to the flock.